Hi and welcome to phase 1 of Python. My name is Madhusudan and I'm going to be your trainer for the rest of the course. I love teaching Python. I'm a data scientist myself, and for the last 14 years I have been working extensively on a whole variety of languages, out of which the most popular favorite of it has been Python. And for the last 8 years or so I have been into teaching various students across the world in Python, and I am so passionate about it, and I want to grow the ecosystem, being an open source community fan and also a member of the Google for Exchange for Entrepreneurs community. And I'm really interested and excited to teach you in Python from basics. So in the process we'll learn about strings, we'll start about numbers and methods and tuples. We'll learn about all the data structures that there are, and we'll slowly advance to learn about statements and the conditions, and we'll begin to understand the object-oriented programming paradigm of Python. And then as we slowly keep making progress, I will be sure to give you a lot of hands-on assignments apart from what we show on the videos. Be sure to practice them, go about doing those assignments, take up those homeworks, and I'm pretty sure by the end of the particular program of watching all the videos of phase 1, you will be having a strong foundation of Python and will be able to build on your learning based on that. And you will be able to write simple programs or automate stuff, but also be able to handle complex computation, and as in your journey of becoming whether a Python web developer or be it a Python testing, or you want to only be a part of learning Python for data analytics, data science, machine learning, or artificial intelligence, so on. So this particular course is going to lay the best foundation for you, and I'm very excited. So let's go learn all about that there is in Python in the next series. So be sure to ask questions, be sure to practice, and once again I wish you all the best. Thank you. Great, let's look at how we can install Python, and I'm going to open a browser, and let's try to see how we can install Python. Installing is simple. I go to python.org, and when I'm on that website, there is an option for downloads. So depending upon your operating system, you will see either you can download for Mac or whatever version you're using, or you can view a full list of downloads. When you click on it, it will start downloading. I'm going to cancel it. I already have Python installed, and you just have to click on it and go through the process of clicking next, and it will install Python. And after you have installed Python, open your terminal or your command prompt or PowerShell on your Windows machine or a terminal on your Linux or Mac, and do a Python -- version, and you will see whatever version I'm using as Python. So it doesn't matter if your version is different, but as long as it is 3.6, we should be good to go with the course. I'm on a different version, but 3.6 is the major version that we want to be on. And after we have installed Python, we need to install something called as Jupyter Notebook, which we will be heavily using as our online IDE, which online IDE is a browser where we will be able to have interfaces like this, where we can type our code and keep all that we typed. This is an example of a Jupyter Notebook. I can write my code and execute and see the output right then and there, like here, unlike running it on a terminal here, which I will also cover in the course. I hope you were able to install Python. Now open jupyter.org and then click on install. Once you click on install, it says prerequisite is Python, which we already have installed. And make sure you have installed Python 3.3 or greater, and then we strongly recommend installing Python using the Anaconda distribution. So we can also do that, but if you've already installed Python, already been working on Python, I'd still insist that you go ahead, click on Anaconda distribution on a new tab, and that will open something like this, and then you can download the 3.6 version, and it's a graphical installer. You can install it by clicking on next. There's also a Windows version, and there is also a Linux version. You can install based on whatever operating system you're using. I'm not going to go over it because it's pretty straightforward. At this stage, you should be able to install this file. Click on download, click on that file, go by clicking on next and install and continue as it gives you an option. And after you've done that, you should be able to open your command prompt, and you should be able to run simple like this by typing Jupyter Notebook. Now, if you are using a Mac PC or a Linux, then you can install Jupyter using pip instead of Anaconda. This is how you install it. These are the commands. Please try this out, and if you already have Python 2 and you want to upgrade to Python 3, you install it like this. Now, after you've done this, you can come back to your terminal prompt. I have something running, and let me stop that. And then once you come back to your terminal or your PowerShell or command prompt, make sure if you're on Windows, you're running it as run as administrator, and you just have to type the word Jupyter and type the word notebook. When you do that, it starts open a Jupyter Notebook, and I'm going to create a new file. So this opens up in the same directory where you ran the Jupyter Notebook command. So I was in a training directory, and inside that I have created this Jupyter file. And once you've done that, click on new. There are other options that you can use. You can start a new terminal, you can create a new folder, you can also write text files, but I think we will be working on Python 3, so I click on Python 3. So this is my Python terminal, and I have so many options like this here, which we will cover in the next class. But for now, I hope you were able to install Anaconda, Jupyter, and Python, and you get this version when you say Python -- version. It could be Python -- version or -- in Windows. You can also right click and on your Python icon on your desktop and see the properties. Now, there's also one more thing you can do is click on Python and activate the shell just to make sure it's working fine, and then type print and say hello world and close this, and when you run it, it should print hello world. Just make sure that this helps us make sure that you have Python running on your PC. Great. I hope you got this, and let's get started with some hands-on coding on Python. See you in the next class. Great. Hi and everyone, welcome to the first session of Python, and in this session we'll discuss about strings. Strings are used in Python to record text information. If you're coming from any other language, you would know what we are talking about. This is something that represents texts, but it's primarily used to record anything that is anything that's a noun. For example, a name or a country or a name of a person or a city and so on. So strings in Python are actually a sequence, which basically means Python keeps track of every element in a string. For example, Python understands the string hello to be a sequence of letters in a specific order. This means we will be able to use indexing to grab particular letters like the first letter or the second letter or the last letter and so on. So in this particular session, we will be learning about creating strings, printing strings, differences in printing in Python 2 and how it has evolved to printing in 3, string indexing and slicing. We'll also look at string properties. We'll understand how string methods work, and finally we'll wrap up the section with print formatting. This doesn't sound a lot, it's very simple, and let's get started with understanding how Python or the idea of sequence is important one in Python, and we'll also definitely touch upon this chapter as we go. So without further ado, let's get started with some hands-on and look at how strings work. In this session, we will be using Python 3. However, I will be happy to highlight certain things that are a part of Python 2 and how it has evolved to Python 3. So if you're coming from Python 2 or working on a project, an older version of Python, then you would definitely be able to relate to certain things. So first things first, since we have set up Python and installed Jupyter and we're all ready to go, I'm going to launch my Jupyter notebook. Note that I have navigated to my favorite directory. I'm just going to do a print working directory, and I have everything stashed in this location. So make sure you create your directory where you want to save all your work, and I also recommend you to follow me as I type. So I'm going to type Jupyter Notebook, and this should start an instance of Jupyter server, and that's an IDE that runs along the Anaconda kernel shell for Python, and it opens up my favorite browser and opens up Jupyter Notebook just like this. Now on this screen you have to click on the new button. We'll go over this sometime later in more detail, but for now all we need to understand is this is a great IDE for browser based application, and I will also be showing you how to execute on that on a Python terminal. But for now, let's use this. This is very comfortable. A lot of data scientists worldwide use and build their code on Jupyter. Its capabilities are infinitely out there, and you can be sure to read through some of the documentation. So let's come back to our topic on strings, and in this let me highlight how it works. So this is a string. Now let's see what happens if I run this. So I can run this by clicking this button, which is some sort of a forward button, or also sort of a play. This button gives us all the selected cells down, and this will put us all the selected cells up, so you can move your cells around just like an Excel sheet. This gives you additional cells to type, or you can simply hit enter, and that gives as well. That increases the space in the cell. And this is a save button, cut and copy your contents and paste. So these are some of the basic features that are there. Be sure to be on code. If you're going to work on anything markdown, you can always use this. So let's say this is where we're going to use hello, and an alternative to clicking on this is also to press shift return on your keyboard. That runs or compiles and executes your code and prints an output. So it's taken into an input, compiled and printed out as an output. So that's also a string. Now this with double quotes is also a string. This also is a string, but this is also, for example, I can also put it in something like this. In Python 2, if you execute this without the print, without the colon, double quotes, like hello world, this would execute in Python 2, and that's the difference. In Python 3, this will return an error. It says missing parameters, because print it becomes a function or a built-in method in Python 3. So if you're coming from Python 2, you can always use print as a function with parentheses, which is a simpler solution than importing anything else to make it work, unless it's a large bunch of code. And then if you shift return, it will give you hello world, and so on. This is also a string. Now why you may ask, why do we have a single string and why do we have a double string in places? The answer is that for situations like this. So for example, if I use this in single quotes, I am I'm very happy. If I run this, this will return an error, because I have used single quotes and only the first letter is considered as a string, and Python doesn't know what to do with the rest. So it's not able to understand the syntax. So we get a syntax error. How do we solve that? So if I have to write the same thing, I would write it this way. I'm very happy. So it allows us to use apostrophes in various formats, especially when you're typing something out there. So this is where strings are useful. So that's how we print a string. If you're coming from Python 2 and you have a lot of code and you have to write something, so you can do something like this: from __ future __. That's a double dund's. It's also called double underscore is also called dund d. That means it helps us call upon certain library functions, which are primitive or something else, that something where you are asking the shell that's running in your PC to talk to the shell that's running on the global CDN of Python, and to import a library that is from the version that is come after your current version. So it says print _ function. So this will make Python 3 available on your PC, and then be able to work out. Since I'm using Python 3, I can suggest you to try this out if you're using a version of Python that is in version under anything before Python 3. And for everyone else who's using Python 3, can ignore this and move on. So I'm going to just comment this out, and if I put a hash, it's a comment, just so you know. So that's about printing. We can also use a function called length to something like this to find out how many characteristics are in a string, or rather, to be precisely put, it will help us to know the length of a string. So for example, I will put something like this and say hello world. I want to know how many memory spaces it's taking, or in other words, what's the length of that string. So it's got 11 characters including the space in between. So we know that strings are a sequence, which means that Python can use indexes to call parts of that sequence. So for example, in this length of a string, it has 11 characters. That means 0 to 10 are being assigned to letters in this box. So let's say H has an index of 0, E has an index of 1, L has an index of 2, and so on. So that's how it started. So in Python, we use brackets, which are squared brackets like this. These are squared brackets that can be used to call its index. So we should also note that indexing starts at 0. So it doesn't start at 1. The first letter is always at 0, and the second letter is at 1. So let's create a new object and explore what I'm talking about, and I'll walk you through a few examples of string indexing. It's very important to understand indexing as a foundation to do anything with strings, be it saving an object into database, or working on JSON, or scraping a web server, or running NLP on it. So it's the basics of how a string works. We are trying to build that right here. So let's give it a bit of more understanding with hands-on. So I'm going to take a variable s and use the assign operation. We'll look at operations later. So I'm going to give it a value, and let's call this hello world to keep it simple. Now when I run this, the string value is assigned to the variable s. So that means if I print s, it should print the value of whatever is stored in it. Or I can also do something like this. It also prints hello world. So now let's start indexing. Okay. So I'm going to take s, and I said we use square brackets, and then I want to call upon this letter h, for example. I'm going to say 0, and then I run it, or shift return, hit shift return, it returns h. So that's what it does. We can use this again to call the index of, let's say, 3, and this returns the L that's here. So you might be wondering whether this L or this L. Let's simplify it. So I'm going to call this, and then it's printing O. So it is 0, 1, 2, 3, and 4, and that the fifth letter of that word is 4. Now, what are the other things we can do? There's something called a string slicing. So we can use a colon to string slice it, along with grabs everything up to a designated point. For example, I'm going to say S. Go and grab everything from the first letter and except the first letter. So that's what it slices, that particular first letter. Now in this case we don't use 0. In this case we are targeting the first letter. So that's string indexing for you, and there is no change to the original s. If you're wondering what's happening with the value that we assigned somewhere here, what has happened to that, if I print it, it's still the same. So we're just trying to do a lot of things that we can with it. So then let's look at some more examples real quick. So if I do a double colon, let's see what this does. So it is able to print something. So here we're telling Python to grab everything from 0 up to 3. So it doesn't include the third index. So you will see this a lot in Python, where statements are used in a context of up to but not including. So we are telling you go print everything up to but not including that. So let me do this with a single quote and see what happens. So that's how that's what it works. All right. So double indexing also works, and if I want to grab everything, just put a single colon, and it prints everything there. And if I have to print the last letter, you might ask, how do I do that? Now, do I need to know the count of everything? I have a really long word. What do I do? So it's very simple. Again, you use slicing, but this time, sorry, you can use a -1. We're printing last letter, right? So this prints the last letter in your string, however long is it. The last one is always -1. So it also counts from, as it counts from 0, 1, 2, 3, it also counts from 0, -1, -2, -3. So let's see what -3 is when we call it's R, because it is -3 is here, -1, -2, -3. So that also works. Now, what happens if I use a colon with -1? It should grab everything but the last letter, right? So I'm going to use this, and I will say -1. So this should grab everything but that particular letter of that index. So that's how it works. So we can also use index to slice and grab elements of a sequence by a specified step size. So the default is 1. For instance, we like we did here in this example, we were able to get every third letter that is out there. So the same way, let's say I'm going to get everything but go in step size of 1. So, and the output is this. So it's step size of 1. So 1 would mean it would grab everything but go in step sizes of 1. But what if I have to grab everything and go in step sizes of 2? And that is grabbing every second letter. So 0, 1 is second, 0, 1 is L, 0, 1 is O, 0, 1 is W, and so on. So 0, 1, 0 and 1 are 2 counts. So it's going in step sizes of 2. Try out more examples like this and see what happens if you try and go with step sizes of 4, and maybe change your string and see. Try out some more examples on your own, but let's try some more interesting things you can do with string. So how do I, there's something cool we can also do. For example, I'm going to do something like this, and with 2 quotes and use -1. Interesting. What does this do? So this actually reverses everything and prints a string backwards. That's what it does. So there's also something called string properties, which I'd like to bring upon. A very important factor is that immutability. So this means that once I have created a string, the elements within it cannot be changed or replaced unless I perform the same operation. What am I talking about? Yes, I'll explain this to you. So let's, we've seen that S print hello world. Now let's try to add something. So I'm going to take the first letter like this, which is H, and I will try to assign it a value of another string called X. So according to Python, we cannot do this. We should because string is a immutable property. That means once it's created, the elements within it cannot be changed or replaced. What happens if I run this? It says exactly that. Another really cool thing about Python is that it clearly tells you what that error means. It's a type error. That means it's something to do with the type of data that we are trying to pass. It's a string, and it does not support this type of an assignment, and it is referring clearly that we cannot edit this. Now what happens is if I have to, what do I do in cases like this? So we can concatenate strings. What do I mean by concatenate is, let's go back. S, as we know, stands for hello world. Now if I can reassign this, or else I can concatenate this, something like this, and then I'm going to type something. So this prints something. It adds something after to that element, but it cannot change the existing element, but it can definitely modify something that is added. But do note that we haven't changed anything that is originally we assigned to S. Now if I have to change anything, I have to take the original variable and use an assignment operator, which is equal sign, and then take that with like this, and I can type Let's print a value now is hello world concatenate strings. So that's how, or you can also do print s in Python 3, so it gets you something like this. So this is how it works, and we can also use multiplication on this. So I'm going to say letter, create another variable called letter, and I will assign it a string value of one single alphabet called z, and if I do letter multiplied by 10 times, it would return the 10 times. So this is how it works. Now let's also be mindful about something more about strings. Like every language has a method, Python also has a method. So objects in Python have certain built-in methods, and they are actually functions that are inside an object. We'll go about it, a lot of methods and functions in our functions and methods chapter that can perform, these things can perform a lot of actions, and methods can perform certain commands or do certain things for us. So we can call methods with a period and then method name. Methods are in the form of something like this. So there is an object and there is a method, and then they take something called as parameters. So now these parameters are extra arguments that we can pass into the method. So don't worry if it doesn't make sense, if it does not make 100% sense right now. Later on we'll be creating our own objects and functions, and we will be able to build on or use some examples of built-in methods in strings. So let's look at some of them right now. All right, so let's go back to what we had originally. I'm going to comment this. This is just the syntax for your reference. I'm going to go back and say s is what we had, right? So let's see what this is. So I'm going to change it back to s is equal to hello world, and I'm going to print s now, so we got it back. So what if I had to change this to everything to, now notice everything is in lowercase. What if I wanted to change it to an upper case? So I just use a method called upper, and this would print everything to upper. And then there is something called lower. This would print everything to a lower method. So that's how it works. So there's also a method we call split, and this splits everything and converts it into a list. Let's look at what it does. Split, and now you can see it's split everything, and I can split it by the letter, put some parameters, right? So I'm going to say split it every time you find the word W in it, and it would print something like this. Oh, okay, W is not defined because I haven't given a code. So always be sure to pass on the code so you can see whenever there is a W, there is a comma associated. You can try a longer string and see what happens and how it separates. So there are a lot of methods that we have covered here, but I'll share the link to documentation, and we will be using a lot of this as we go. But for now, this is to get us started. Last one I would like to share with you is called print formatting. There is a method called format, and as an exercise or as a homework for you, I'd really want you to visit python.org and look at how the documentation is structured, and understand it's very important that we know how to code, but it's also important to know where to look for in the documentation when we're really stuck. So if I want to look at Python strings, it's very simple. I can either just type string, or I can go to Python documentation and go to developer guide and understand how this works. But the job is to understand how formatting works. So I'll not tell that to you, but as an exercise, do work on what it is and how formatting works. But for now, let's take a pause. I will let you search on your own and understand and try out how format method can be implemented. And I'll pause a bit. All right, go ahead and search and try out. All right, so I hope you have tried it, and that was I hope that was easy. And let's try an example and see how this works. Okay, so I'm going to say write something like this. Okay, and let's try the format method. and I'll use the format method. So now the output is that the format method really formats it something like this and converts everything into a text format and puts it along within a single string. So we'll revisit this string formatting topic in later sections when we're building our projects. Great. All right. So I hope you got a good hands on working on strings, and I hope you were able to follow me along with your coding yourself. And if you haven't understood anything, please feel free to ask. And this is just a basic introduction to strings. There is a whole lot more we will be looking at as we go. This is to get you started. I hope you enjoyed the first session. Next up, we have numbers coming up, and see you soon in the next class. All right, welcome back, and I hope your learning is coming through. We're at the end of learning about data structures, and the one that remains is set and booleans. These are the two other object types that we are left to cover. Sets, as we know, is an unordered collection of unique elements, and we construct them using the set function. Let's go ahead and see how this works. I'm going to come here, and then I will say create a variable, or which we will create using the set function, and then this is our way of telling Python that whatever we are creating on this variable is going to be a set. And I'm going to x.add, and I will add 1, and I will add 2, and I will add 3. Now if I print, it has got 1, 2, and 3. Notice the curly brackets in that does not indicate that it's a dictionary, although you can draw analogies that this set being a dictionary with only keys in it. It's not that very relevant, but we know that set has only unique entries. So what happens when you try to add something that's already in a set? So I'm going to add another 2 here. Oops, that's my typo. Okay, and let's print, and look at that it has not accepted a same value on top of what was already existing. It has tried to maintain that uniqueness. It does not place another 2 there, and we can create a list with multiple repeat elements to get a list of unique elements. But let's try what happens if I create a list now and try to see if I can convert it to a list and see what happens. So this is my list, and I will say 1, 2, 3, 4, 5, 6, and I have some repeats here. I have a 1 repeating, I have 2 repeating, for example. And what if I cast set to be a L, and then I run this? Notice how the list is now converted into a set. Anything that's repetitive is discarded, and the uniqueness is maintained. So you can do this if you have to remove anything from your file that is repeated. So you can now use this method on anything where you need to maintain uniqueness. That's about sets. Let's move on to learn a little bit about booleans, which is where Python has a predefined true or false that displays the things that are basically 0 or 1 or binary, and it also has a placeholder object called none. Let's look at some basic examples that we need to know to move on. So I'm going to say a is equal to 1, and then I will say is a lesser than 3. It says true, yes, 1 is lesser than 3, and then I can ask is a greater than 4. It says no, that's not. So that's one example, and we can at a later time use a lot of list comparisons and so on. And I can also say b is equal to none, and I can say is a equal to b, and it is false because they're not. So that's it. Next we'll look forward for you to come back and do a short assessment, and we continue learning on how to program something more complicated, and as it becomes fun as we go. And let's move on, and see you in the next class. Welcome back, and this is about chain comparison operators. In this session, we'll come across a very interesting feature of Python, and we explore the ability of Python to chain comparison operators to perform a sort of a complex test. So you can use these chain comparison operators as a shorthand for a larger Boolean expression. And why are we focusing so much on Boolean is also because that we will be using them as critical elements, especially during our object-oriented programming. And while creating some functions, we need to know how to sort of negate certain things, how to falsify something, and how to handle something that's true, and so on. So it's very important. We're laying a great foundation of being able to understand Python's data structures and certain privileges that or certain features that we can use. Now, we'll learn about chain comparison operators, of course, but I'll also introduce you to two other very important statements in Python, which is and or, which are also evolved in Python 3 a little bit more than what it was in the previous version. So let's get started. I'm going to switch over to my screen here, and I'm going to start with some hands-on exercises. Great. So let's say I'm going to chain a comparison. What do we mean by changed comparison operators? Is there is more than two elements that are being compared, or more than two operands that we are comparing. So in this case, we are looking to see is 1 lesser than 2 or 2 is lesser than 3. And if all the statements are true, it will return a true. And the way I would read it is that if 1 was less than 2, and if 2 was less than 3. So we could have written this using a AND statement, which would give us a better return of answer, and then I would see it this way. So just similar to that. So as you may know from mathematical logic that, or any Boolean logic that you may have studied in high school, that AND is used to make sure the two checks have to be true in order to have the outcome as true. Let's see another example. So I'm going to say 1 is less than 3, all right, and 3 is greater than 2. This also will return a true. And I could rewrite this with AND as 1 is less than 3 and 3 is less than 2. So when you use AND, both the conditions have to be true, only then it would return true. So I switch this, I make both of them as true, it returns a true. So it's important to note that Python is checking both instances when we use the AND operation. What if I want to use only one of the operations and I want to return true only if one of them are true? And let me introduce you to the OR operand. If 1 is equal to 2 or 2 is less than 3, then return a true. So it will return a true because one of the statements is true, and this is clearly because of the OR operator, and we need one or the other two to be true. So let's see another example, and then we can drive this home. If 1 is equal to 1 or 100 is equal to 1. So note I cannot use a single equals operator, because that means a single equal sign is a assignment operator and not a comparison operator. So this is a single equal sign is used to assign a value to a variable. A double equal sign is used to compare two objects or two operands. Now let's say if what this will return would be true, right? So go ahead, and I would take you to a simple quiz, and so we can check your understanding. Yeah, welcome back, and I hope you're enjoying this session on Python. This is our second chapter, and I hope it's very easy so far. And in this lesson, we'll be talking about numbers. We'll learn about the type of numbers in Python. We'll learn about basic arithmetic operations that we can perform, and we'll also understand how object assignment is done in Python. So let's get started with some hands-on. And Python also, before we get to that, Python has various types of numbers. Let me spend a moment here explaining the different type of numbers. We'll mainly focus on integers and floating point numbers, which are very important for if you are taking any path in the route of data analytics or data science, machine learning. AI, and so on. So integers are just whole numbers. They are either positive or they are negative. For example, 2 and -2 are examples of integers. Floating point numbers in Python are notable because they have a decimal point in them. Or use an exponential, we call it e. We'll see how that is used, or to define the number. For example, 2.1, 3.4, anything with a decimal are floating point numbers. So also 4e2, which is a exponential of 4 times 10 to the power of 2, which is written 4e2, is also an example of a floating point number in Python. So throughout this particular course, we will be mainly working with strings or simple float numbers, which we can see a lot of examples. So I'm going to talk about numbers more in detail. We'll keep visiting back as we cannot do it without numbers. So let's jump right into some hands-on numbers and see how it works. Great. Now I have my Jupyter notebook open, and I'm going to perform some simple basic arithmetic operations, like let's say 2 plus 1, and see it returns a simple 3, and I do a subtraction. It returns you next subtraction. Very simple, very straightforward. Nothing you have to worry about putting in any more semicolons or anything. It is so simple. And I divided 3 by 2. I multiply 4 times any number. Let's say 4 times 9, and it gets you 36, and so on. So that's how numbers work. But we could also do something where we can use Python to do something more. Let's say what if I have to do 2 times 2 to the power of 3, or 2 cube. So it's very simple. I use 2 star, and then I do this. So it's 2 times 3 is 8. We could also do square roots this way. For example, I can do this 2 to the power of 0.5, let's say, or let's make it something even more easy. So square root of 4 is 2, and this is there. Then another important part of Python is that it follows order of operations. So it always prioritizes multiplication over addition, division over subtraction, and so on. So let's see an example. So I'm going to do 2 plus let's say 4 plus 10 multiplied by 10 plus 5, and what do you think the result could be? So it's 109, because it's multiplying first and then doing the addition. So it's 10 times 10 is 100, 100 plus 5 is 105, and plus 4 is 109. So that's how it works. In cases like this, when you can use parentheses, very simple and straightforward. So I'll do the same thing inside of parentheses, and you can see that it is completely handled differently. You'll get a completely different result. So be careful when you actually use multiplications and so on. Great. So this is very simple about numbers, and let's try something where we can assign names and create variables. So we use equal sign to assign labels to variables. We'll do assignment operations explicitly in more detail as we go, but for now let's just do a simple assignment by equals, and I will assign a value of 5. Now I can call my Python script, and this will treat in the number 5. So I'm going to say, so if I say print a, just like we used to print a string, this is holding the value of 5. Now I can do a plus a, and this will return 10. What happens on reassignment? I take a and I assign it 10, and I print a is 10. So I can do a is equal to a plus a. So now a value is 10, so I do a plus a to return 20. So I'm going to print a, it returns 20. So it's that simple that we can assign values, but there are certain things, there are certain Python rules that we should know, and especially when we're doing an assignment. So while doing an assignment, you cannot have names that can start with a number. So I cannot assign 4a is equal to 5. This is not possible. This is not allowed. This is not like high school maths that you can try to assign something. This has to be a name. only then it is acceptable. There cannot be no spaces. I cannot have a and I cannot have a space b is equal to 5. Let me leave it as it is. And this is not possible. So, and you cannot use any type of symbols that are on the keyboard, on the numeric pad out there for you. Any of these symbols are not allowed. I'm going to just put all of them here. None of these symbols are allowed. So it's considered best practice. There is something called as PEP 8 standard. I'll leave them as it is. PEP 8 is a standard that defines or controls that names are there, and it is also considered that your variable names are lowercase. It's not that you cannot assign capital cases, but it's important that we stick to the standard, and so that our code runs reliably and we don't make any mistakes. So let's all follow the standard that is being defined by Python. Do look it up. Look for PEP 8 Python in Google and you'll find the documentation for the Python version you're using. And now that we have learned so much about numbers and arithmetic operations and also assigning variables, let's quickly build something that's fun and let's make it more interesting. Let's say I want to build a calculator that tells me how much I need to pay tax in the simplest way possible. So let's say I make $100 and my government charges 10%, wherever the country I'm in charges 10% of my tax, and I need I'm really bad at math, let's say. Maybe I don't know, but let's say I'm bad at math and I need this calculator to every time tell me, depending upon what input I give in about my income and the interest rate, it should calculate and give me the tax I owe the government. So I'm going to say, so let's start with the first one. Let's say I mentioned my income is $100, right? So I'm going to say my income. I use underscore. Note I cannot use a space. So when I come across words which 2-letter words or 3-letter words, I use an underscore and then I assign a value of 100. And then I also mentioned that my tax rate is 100%. So I'll put this as, I can put it as 100%, but this is not acceptable. So what is a percent? When you say percent, it is per 100. So what is 10%? It is 10 divided by 100, which is 0.1. So I'll put 0.1. Now I need something that calculates my taxes is equal to my income multiplied by tax underscore rate. If I put 100, I would do it differently, but since it's already divided, I would put it as 10 divided by 100. My income multiplied by 10 divided by 100 would return the right result, but since already I have put 0.1, I can simply multiply it by this. And let's see what the output will be if I print or just call my taxes. This should tell me what I should pay, and I should be paying okay, I have done an error. So I hope you notice what is the error that I put. I have put 2 stars. So this is something we all make. It's completely normal to make errors, so that even experts, even experienced are making errors. So you don't beat yourself up if you run into making a syntax error, just like I did. And now it should return the error as I pay $10 to the government. So what have we learned? We've learned some basics of numbers in Python. We also learned how to do arithmetic and use Python as a basic calculator. We then wrapped it up with learning about variable assignments in Python. So that's great. So let's go about learning more on what are lists. Earlier, when discussing strings, we introduced the concept of a sequence in Python. So lists, although are thought of the most general version of a sequence in Python, unlike strings, they are mutable. That means elements inside a list can be changed. That's the difference between a list and a string. A string is immutable, while a list is mutable. So in this section, we'll learn about how to create a list, how indexing and slicing lists work, just like we did in strings. We'll also look at some basic list methods, we look at nesting lists, and I want to introduce you to something called as list comprehensions. That is something we'll look at it very deeply later on in the class. But for now, I want to introduce you to the concept of list comprehension, so it becomes easier to connect at a later point of time. So let's go ahead and see how we can construct lists. So I'm going to fire up my notebook, Jupyter notebook, just like this here that you can see on the screen. And now I'm going to type certain things the way I can create a list. So a list can be created simply just like the way you do a string by giving it a name. And we use square brackets to create a list. And I'm going to give it some values like this. And then we just created a list of integers. But lists also can hold different object types. For example, it may not be only numbers. So I'm going to take this and I will add an apple. Then I will add number 3. Then I will add something called, let's say, a jet plane, just anything that you fancy. And then I'll put some numbers, or I can put something floating as well. So it can hold a whole lot of things. So just like strings, we can use the length function. I'm going to say length and pass on the parameter, which is the name of my variable whose length I would like to measure, and it returns to me as 4 because there are 4 elements inside my list. And I can also do many other methods just like we did in strings. Let's see what happens if I have to slice it. So I'm going to create another list or edit this list and say 1, 2, 3, 4 and 5 and 6 and 7 and 8 and 9. Let's make it 9 like this. Oops. Okay, so I have a really big element that should be good enough for an example. And now I call upon the first element, which is 0, and it brings me the first element, which is 1. So I want to call upon, let's say this is, I'm going to change this to something, and then I call upon 0, 1, 2. So I'll say my list and say 0, 1 and 2, and it brings out that. So I can also do slicing the way we were doing in strings. Let's see what happens if I do my list and I say :1. So this grabs the first one except everything else, and I put the same thing, the colon after, then it prints out the opposite of it. It grabs everything except the first one. So we can also use the plus sign to concatenate. So I can say my underscore list, and I can say plus, I can add new item, and then it adds new item. I can also assign this whole thing like this. So I can say my list is equal to, my list should have a new item. Now there is something else we can also do. I can, let's say I want to grab the first element. Let's explore how immutable or mutable this is. And I want to take the third letter and I want to replace it with a string called, let's say, orange. And now I want to print my list, and this will print. You can notice that orange has come in the place of the third index. So that is how one of the methods work. And then you can reassign and try out a few other things. We can also use the duplication. So I want to say my list multiplied 2 times, and it will give you the output multiplied in steps in 2 times. So that is something to do with something basics about my list, about lists. Now if you're familiar with any other programming language, you might start to draw parallels between how arrays in other language and lists in Python work. So lists in Python, however, tend to be more flexible than arrays in another language for two main reasons. One, they have no fixed size. That means a string can be as long as you want it to be, and there is no fixed type constraint. Like we saw above, that I can add a type number, I can add a number type or a string type or a float type. So anything can be put into lists, and they're also very much mutable. So that makes lists great to work with. Let's do some methods, basic list methods in some examples. I'm going to create another list called L, and I will give it 1, 2, 3. And now notice I made a mistake. So this became this is a set actually, but this is not a list. So I need to give it a square bracket. Yep, I keep making these mistakes repeatedly so I can show you how you can avoid making mistakes. So I wanted to remind you that we need to use square brackets, and that's how Python will understand that you've created a list. Now I take this L and I append it with, let's say, I will say something. Going to say, well, what do we do? Okay, I'm going to give the name James Bond. I like James Bond. And then see what happens if I print. Okay, tuple has no opaque. So this was not run. It became a tuple. Okay, great. So this should now, let's say, print L, and it should print that it has added James Bond. So if I put the square brackets like this, it's a tuple. And then it also tells you, if you make a mistake and you're wondering what have I created, Python always will be there to remind you that you made a mistake, and the errors will be precise. I can now, coming back to the methods, I can also pop something. So I just say pop is another method. I can pop anything. By default, it pops the last one, but I can also control what I want to pop out by typing the index. So I say pop 0, then pops the first one. Let's see what is L left with is 2 and 3, because the first and the last one are taken off. So try this out, try more of variables, and then see how this works. And well, you can also do something like this. So it says something like this. I'm going to create a popped item as a variable, and then I will say, so whatever you are popping out, you assign it to my new variable popped item. I can also do an assignment, so that way my L is left with only 2, but 3 is assigned to another new variable. So that is how it is done. So it should also be noted that lists indexing will return an error if there is no element. I'm going to create another index. This time I'm taking M, and I'm going to create another index. Okay, let's keep it at that. Now I execute this so that it's saved in memory. So if I try to get let's say there are 7 elements in this, right? So I'm going to call upon the 7th element. It will print. What happens if I call upon the 8th or 9th element that does not exist? It will tell you that index is out of range. So if you get into an out of range error, that means there is somewhere in your list or where you have tried to do something with the index or the sequence, and the range is a mismatch. So you can always come back and fix that error now that you know where you run into an error like this. All right, now let's move on. I can also do a sort list. Let me give some more spaces here, so we have some space on the screen. Great. Let's create another index. So I'm going to create an index called alphabets, and just to keep it, I'll create them as AB, and I will have some random letters. Just want to make sure I'm not repeating anything. A, G, H, Y, T, R, X, S, X, S, Z, V, B, and M. Okay, that should do, I guess. There is a method that we can use. Okay, this is a string, right? So notice how I made an error. So I'm going to try this again. So always be sure of what you do. Right, and I'm going to add something. I hope some of you caught that error, and it's, you know, it happens with everyone. Okay, so let's give it at that. And now this is my new list of alphabets. I want to sort them up. I'm gonna, let's just make it more. Okay, I have a C here. Okay, so I want this to be sorted. So there is a method to sort, which is ab dot sort, and then if I print ab, it is now sorted. Oh, I have to run this again, and then run this, and we run this. Now we can see that the ab is sorted. So you can try out a few other methods that are there. For now, this is good. We're making good progress. Let's look at how nesting works. Nesting is another feature of Python data structure that supports to put a list within a list. So that means we can have data structures within data structures. Let's look at an example. Okay, so I'm going to create a list, and I'd have something like this, and then I'll create another list, and I will put in some other numbers. Not that way. Okay, I have a problem with the keyboard maybe. Okay, and then I have another list. Oh, all right, so now I have this. Let's say I can have something called as matrix, in which I have this list within the list. So I have 1, great. Now this is a matrix of lists, and we have a list 1, 2, and 3 as lists, and matrix is also a list. Now I can use indexing to grab the first one. So this is the first list is grabbed. What if I have to grab 55 from list 2? How do I do that? So I can do it like this. I'm going to call the first one. So this is 0, 1, and then I will use double square bracket, which is second square bracket, and then I will say 0 and 1. So this should give me 55. So try to see if you can print 678 the same way, or try to print 67 the same way. So that's about how you do it for your exercise, and give it a shot, and I'll be back in a sec, and I'll show you how it's done. Okay, I hope you tried how to do that, and you were able to do it. I'm going to try this to print 67. So I will first call the list number 3, which is index number 2. Okay, why do I have single quotes? Okay, I'll be calling list number 2, and I will call 0, 1, and 2. So that way I'm calling list number 2, and we call 67. If I have to print, I would call print 678. This is how we do it. We're printing 678. I hope you understood that. The final thing that we're left with is list comprehensions, which is an advanced feature that allows us to quickly construct lists. Now, we need to understand for loops to be able to fully understand list comprehensions. So don't worry if you don't completely understand or it doesn't make sense. Just feel free to skip this since we'll come back to this later. But I do really insist you just look at this. It won't take a lot of time, and if it makes sense to you, that's great. If it doesn't, shouldn't matter. We will be covering this later. So I'm going to create a first column, a variable called first column, which is going to be our comprehension. and we're going to deconstruct the for loop within a list. So I'm going to take a list and say row 0 for all the rows in my set called matrix. Return every first, if I have to return the 1, the 44 and 654, I want them 3 in the list. How do I do it? Is by list comprehension. So okay, I should say in matrix, and then there is something, I have made an error. Okay. Oh, okay, for row in row matrix. So now you know what I made a mistake. So whatever you put here has to be put in here. It could be anything, say anything, and I have to repeat that here, anything. And now I say first call, and this prints the 1, the 44 and 54 just like we wanted. So that's how we can use the for loop to construct list comprehensions that will help us to quickly create lists from a group of lists or nested lists this way. So I'm glad that you were able to watch this so far and you were able to understand. So don't worry about it. We'll look at next sessions, and we'll cover this in much more detail later on. See you in the next class. Welcome back, and in this session we'll be talking about comprehensions, a very important part, an advanced feature of being able to handle lists. And Python has a way of handling sequence operation in addition to what is already available and list methods. There is this advanced operation called list comprehension. I had introduced you to this during our session where we went over lists. But this time we actually going to learn more about it and master it, as list comprehensions allows us to use the lists in such a way that we can build out lists using a different notation, and it is some sort of a loop built inside brackets. Let me quickly give you a sort of an example, and let's switch over to code here. All right, now in here let's look at how we can create a list and also build it out with just one line of code. Now I'm going to use all that we have learned so far in terms of grabbing something and using the for loops especially. So let's say for every element A, I'm going to say for every element A for A in letter word, right? And let's see what this does. Okay, so I just created a list, and that list is all about creating or separating a list. I could put this as X, it doesn't matter. I can call this X. So like the same properties apply that we learned in the session of for loops. What have we just done? So if we print out, look at that. We just created a list from a word. This is the basic idea of list comprehension. Now, if you are familiar with a mathematical notation that I have it on the screen right now, this format should feel familiar with an example. So for all values of x is 2 in the set 0, 1 to 10, and it would mean that you are referring to every value that is 2, so inside your list. So let's see some more examples, and it's important I take math references. It might be really hard for you to understand, but that's the best way to understand this. A little bit of high school math won't harm you in any way. After all, we're going to learn data science and data analytics and handle data, if not any of this in Python. So let's try to see if I can put the same mathematical statement that I showed you on screen, and I'm going to say print all the, let's say square numbers in a particular range. If someone asks you, create a list and says or you're at an interview and tells you to create a list of even numbers in a range of 0 to 10, this is how you do it. And if you do it in any other way, you're not a Python expert. So listen closely. So I'm going to take this. We know that I need to square every number, right, for x in a range. So the challenge, the task that you're told is print or square every number within a range of 0 to 10. So I'm trying to make that happen. So I need to square a number, so that becomes my first condition. For every number in range, I will now say 0 to, so I know that if I put 10, it will only go till 9, so I'll put 11, so I'm covered. And now see what happens if I just print the list. So there you go, it squared every number from 0 to 10. So that's still so simple that you can do this. Now it becomes even more fun if you add if statements. So what if I have to check for even numbers that we tried previously using the modulo, and I want to check not just how to print, but also check in a given range, and I don't even have a list. What would you do? You do list comprehension. So I want to check for even numbers in a range 0 to 10. So that's the task I'm trying to solve. So this is how we do it. For all values of x in the range function is important, and that's a method that we use. And if x, and I'll use the same thing, the modulo theory, that anything divided by is equal to 0. So if the value is 0, for all the numbers in range, make a list out of it. So that's what this does, and when I print that list, we've got all the even numbers. So try this out. You can also do more complicated arithmetic. For the love of Python, let's try to build a currency converter, or let's see, we have a choice here. We can build a currency converter, which is fairly simple, or we can do a Celsius to Fahrenheit conversion. So I'm going to try this now. Let's say I'm going to convert, okay, Celsius to Fahrenheit. I think I got the spelling correctly. If I haven't, don't really judge me. I'm trying really hard. Okay, so I need to know how to convert Celsius to Fahrenheit. So I will open Google and I'll say formula to convert Celsius into Fahrenheit. Let's see what that comes. Okay, I will click on whatever the first result is. Okay, so they already got this. I don't need to go anywhere. Google exactly knows what I'm looking for. But anyways, here it is. So let me go back. That was a better example. Okay, so I need to multiply 9 divided by 5 and add 32, right? So either I multiplied by 1.8 or 9 by 5 and add 32 to my temperature. That is exactly what we will do. Now I'm going to say, let's say there is a value of Celsius that I need. Then I need a Fahrenheit, right? And then I need to print Fahrenheit, correct? So I'll come back to that later. So let me say I am given a list of, so there is 0 degrees in Zurich, and there is 10 degrees in New York, and then we slowly come down. There is 20 degrees in Texas, and let's put a floating number just for the sake of it. And then we go to, let's say, Delhi, and Delhi right now is at 40 degrees. It's really hot. I don't want to be there. And let's say you come down south of Bangalore, and then you are at, let's say we're talking about 25 degrees. It's a little cooler. And you go further down towards the pole or towards north, or let's say you're somewhere in Indonesia, for example, now that we've come to Asia, and we are at 34 degrees, and now you're in London, and it's cold winter going on there. There is some storm coming in, snowstorm, and we are talking about -3 degrees. So let's see, we have a negative, positive, float, all type of integers covered, and let's see how our function will operate if I put it in this. So at first I need to put this inside because I'm creating a list, I put a square bracket. That's a mandatory requirement. Now I know that I need to use 9 divided by 5 multiplied with my temperature, and I need to add 32 to it. That's the formula, correct? So 9 divided by 5 and 32. And so simple, it's so simple. And after that, let me put this whole thing inside the brackets, and I need to be aware of order, correct? Order of operation. That's why we learned order of operation in arithmetic operations before. And after that, I need to use my for loop for every temperature. I'm addressing this as temperature. For every temperature, in what? Yes, you're right, in Celsius. You got that. And I will try to see what happens now. And I'm asking it to perform all of this operation, and then for every element you go over all of this, and then I want it to print Fahrenheit. I could do print Fahrenheit, or just simply put Fahrenheit, because hey, we're working on Python and we don't need to be so formal with it. And let's see what this does. Excellent. So we're getting, so 0 degrees is 57.6 degrees Fahrenheit, 10 degrees is 75. Let's take the hotter one. It's about 129 degrees Fahrenheit, and then -3 is not handled. So I want you to see how you can look at handling this, but uh, you're not affected by -3, right? So we are actually 52.2 degrees Fahrenheit is really cold, and yeah, that's you can see we have been able to operate all of that. So I wanted to try this as an example. We can also perform a nested list, right? What if there is a list within a list? How are you going to handle it? If you remember, we covered nested lists earlier. I'm going to take an example of that. And let's take that example of having a square number for whatever we had earlier, and I will add another squared number of whatever we tried for x in range. So I'm trying to square and square again. So if I had a result 4, it would be 4 times 4, it should show 16, 9 times 9, 81. So I'm double squaring them. You know what I mean? And I'm giving them the same range that we gave earlier so we can easily relate to it. And I'm going to call the list, and there you go. So we have been double squared. That's about lists. Now I really want you to try this out. It's something that should stick with you, and all of it will come in handy if you know this. So practice is very important. Um, I will share with you some links that are websites that you can go and test your skills, and you can find them here. And after that, I would really look at how to work with different list comprehensions, and you should feel comfortable reading and writing basic list comprehensions after you've watched this video and after you've practiced this. All right, see you in the next class where we deal with methods. Welcome back, and we're learning about dictionaries in this session. So we've been learning so much about sequences in Python and how they're indexed and how we can run some methods on the indexes. But now we're going to switch gears and learn about mappings in Python. Now, if you're familiar with languages, you can think of these dictionaries as hash tables. Now, I'm going to cover a lot of topics in this dictionaries where we'll talk about how to construct a dictionary, how you can access objects from a dictionary, how you're nesting dictionaries, and we'll again, as our routine goes, we'll perform some methods on dictionaries. So what are mappings? Mappings are a collection of objects that are stored by a key, unlike how we had in sequence that are stored objects by relative position. So if a position is called, like say I wanted to, let me remind you, if we had to call a method in string number 4, index number 4 in a string, we would call that. But here we call upon the key to get the particular value associated with that key. So this is a very important difference since mappings don't actually retain the order. They've got nothing to do with sequence, but they have everything that is defined by a key. So a Python dictionary consists of a key that is associated with a value, and that value can almost be anything of any Python object. Let's see how we can construct a dictionary and understand how dictionaries work. Let's get started with some hands-on. Now I have switched over to my Jupyter notebook, and let's try to create a dictionary. So I'm going to call it a dictionary. My let's say dictionary, and I'm going to give it a value. Now we use curly brackets, and this is how we create a dictionary. So there is key 1 associated with value 1, and then there is key 2 associated with value 2, and then there is key 3 associated with value 3, and so on. So this is a simple dictionary, and we use curly brackets, and then we use the colon sign to signify a key on that. So anything on key and value, so anything on the left hand side of this colon is considered a key, and everything anything that is on the right side of this semicolon is considered a value. Great. So that is how a dictionary is created. Now this, I run it and my dictionary is finally created. Now I can call upon the values when I call by the key, the same way we used to call by the index. I use square brackets again the way we used to for indexing, and then only this time I will use the key that I need to call upon the value of it. So this is very important to note that the key and value and the flexibility in the data types they can hold. Now I can use the same thing. Okay, I'm going to make some changes here, and this time I will have some values. All right, and I'm going to change the value of this to be a string, and I can go on even more. I can say I have a list, something like this, and I can also add another key, key 4, and then I can name it anything. I can name this anything. All right, it's just a name of the key that you can remember in your programming, and then I can even add a tuple, or let's say, all right, or let's just keep it simple. We have got it so far, and this is how we have a dictionary. Now let's call a number and see what happens. So I'm going to say my dictionary, and I'm going to call a, let's call key 3 and see what happens. It returns a set. So this is how dictionary works. So I can also call an index. So what if I have to call, you might be wondering, if I want to call the number 33, how do I do that? So I take the key and then I use index on it. So I want to call index on it. So if I want to call 33, and that is okay. Oh, key 3 has this. Okay, there is a problem that I made, is I call them like this. So key 3 is now a set, and now I've got 33. So I hope you noticed the error I made. Again, I'll keep repeating those errors, and then so that you all know that these errors are normal. Now that is how we call upon the elements that we need to call upon. Now how do I call methods on this? If you are wondering, there are so much, it makes it so flexible now. So I'm going to call my dictionary, and I will, let's say we call key 2. All right, and in that key 2, or let's keep it key 3 because we are going to try something different. I'm going to add another key here. All right, just for our example, let's say key 4, and I'm going to add a list of okay, item 1, item 2, item 3, and so on. All right, so that's our list of strings within a key, and now I'm going to call upon key 4 here, and in that key 4 I want let's say, all right, let's keep it like this. In that element I want to call the first element, which is item, and I will run a method of upper on it, and then it is converted into we can also affect the values of the key as well. For instance, I can take, let's say, and I take key 1, it's my underscore, and I take this key 1, and then I will take this, minus it with 1 to 3, and let's see what the value will be if I call upon it. So you see it has changed, it has been reduced by 1, 2, 3. So we can perform operations both on key and value. Now there's also, Python has a built-in module for self-extraction or multiplication. So I can use something like this. Instead of doing this whole thing, I could simply take this and say minus and equals assignment. It does the exact same thing what we just did above, and it subtracted 123 more out of our value. So this is how it's done. So we can also create keys by assignment. So let me show you what I'm trying to say. So we could continuously add on to the dictionary. So I'm going to say D is equal to an empty dictionary. I just initiated a empty dictionary, and in that I can say and then put a value called cat. Now I can also say D and then say age, and I can say 3, right. So I can go on D and say name and say kitty. So that's how. So we can do this with any object type, it doesn't matter. Now if I do a show of D, now we have our dictionary created. So that's how it is. And just like how lists can nest with lists, dictionaries also work. So I hope you are able to see how powerful Python is with its flexibility of nesting objects and calling methods on them. Now let's try what happens if I try to list them the same way we had a list within a list created as an example last time. So I will go back or fall back on the same example that we had of key and value. So just so we understand how this works. So say key 1, and then this key 1's value is another dictionary nested, and then the value of this is another sub key. Let's say it's inside of another and then the value is finally is here. So that's it. It's quite an inception of dictionaries. So now let's see how we can grab value. So there's this one value in every case. So how do I get to print that? So if you count the number of curly brackets in the end, that will tell you how many nested dictionaries are there. So we have 2 nested dictionaries within a parent dictionary. So that means we need to be calling 3 dictionaries to get to the value, because they're nested and subnested within each other. So I'm going to have to call upon, means I will say key 1, then I need to call nest key, then I need to call the key of subnest key. Only then I will be able to get the value out. So that's how it is. And there are also a few methods we can call on dictionary. So let's try it some more of these examples. So I'm going to take this. Let's create a simple dictionary, and we have key 1. Then I have a value associated with this is that, and then I have a key 2, and I have value associated as 4. Then I have key 3. I have the value associated with it as 6. Alright, so now we're going to try to see if I want a list of all the keys only. How do I get that? So there is a method to get only the keys, it's called keys, and very straightforward. I get all the keys. If I want only the values, it just type the values, gets you only the values out. And if I want the items or a list of tuples, we'll see tuples in the next session. So if I want a list of all tuples, I just say items, and this returns in a list of all tuples. So hopefully you now have a good basic understanding of how to construct dictionaries. There's a lot more to go in here, but we'll revisit dictionaries at a later time. And after this section, we will be able to know how to create a dictionary, how to retrieve values from it. If you've achieved that alone, it's a great feat, and you can tap your back for now. And let's move on to learn about tuples next. Welcome back, and in this session we will be learning about tuples. I hope you have been able to practice, follow along and type your own code. Now in this session we will be learning about tuples. So tuples in Python are very similar to lists. However, unlike lists, they are immutable. Just like strings are immutable, so are tuples, and they cannot be changed. Now you would be using tuples sometimes to present something that needs to maintain data integrity, just like an account number or a social security number. So you don't want any object to come and change it. It could also be used for protecting dates on a calendar or days of a week. Some places where you don't want to actually save or change or have any other program or a function come and manipulate that. Those are the situations where you use tuples. In this section, we'll get a brief overview of constructing tuples. We'll look at basic tuple methods. We'll understand about immutability and when to use tuples. So let's look at how to construct some tuples. All right. Great. Now let's construct some tuples as an example. I'm going to call a variable t and assign it a tuples of 1, 2, and 3, which and we can also create tuples with mixed types. That's not a problem. Now I'm going to call run the same methods. Let's say length, that way the way we used to do it. So there are 3 elements, and you can also mix it with other objects. So for example, we can say t is equal to, you can say 1 and then say 3. So t also will print that out for you. Then we can call indexing the same way, and then we can do slicing. You got that. And there are certain basic tuple methods. If I want to know the index of 1, then it tells me that index is 0, and I can get the count, or let's try to take this and change it to now I want to see how many times the letter 1 is printed. I will use the count method for that and pass the parameter that I want you to count this object, and it's repeated twice. So I really want to stress that tuples are immutable. Let's see an example. So if I try to take this to first object is 0, and I want to change it to, let's say, something, okay, and it will return an error that it does not support changes. So this is an error again of type that tells us that because of immutability, tuples can't grow. So once a tuple is made, unless you take it and write it again in your program, you cannot use any method or anything else to add to it. So that's how it works. So I try to append, let's see what happens. I want to use a method on it, for example, and I will say, let's say I'm just going to say orange, and append. Now it tells us that it has no attribute and it cannot append. So you might be wondering, why bother using tuples when they have so many fewer available methods? But honestly, tuples are not used as often as lists in programming, but we do use them when immutability is necessary. So like I said, when you have to handle count numbers over large data sets, or you want to extract something that should not be changed, and scenarios like where data integrity becomes very important, you use tuples, and so be it that we use them seldom or rarely or very little, but it's very important that we use them. So I hope you understood what tuples is, and that's all there is to learn about tuples. Do practice them, try it out, and next up let's learn about files. Great, we've made it so far, and I hope so far has been so good. And in this particular section, I will be introducing you to Python statements. It's a quick overview, but we'll dive deep in as we go. But let's get the basic understanding first, and we'll emphasize the difference between Python and other languages so you can relate to it better. Don't worry if you're starting Python as your first language, you can still be able to relate to it, because I'm going to take some very generic examples. So what are we talking about when we say statements? What exactly is a statement, and how do I approach learning this particular statement thing? So there are two reasons we take to approach for learning the context of this Python. Number one, let's say you're coming from a different language, like I said, this will really help you accelerate your understanding of Python. And secondly, you'll be able to read other languages more easily in the future and pick up any language that you need to. So we are essentially laying a sort of a foundation for you. So you will be able to pick up any language and understand statements and comprehend anything better. Any object-oriented programming should be a piece of cake after this. So let me give me your 100% focus, and let's get started. So let's just do a quick comparo of how Python versus other language. Let's create a simple statement that says if A, when I talk about a statement, it is usually with a condition. If I want to call I'm a Superman is a statement, but I'm going to phrase it differently. I would say if I had the superpowers, I would be a superhero. Now that's a statement that we are talking about programmatically, and that's a conditional statement because there is a if associated with it, right? So if a spider had bit me, I would have been a Spider-Man. I know it essentially would not have been the case, but I'm just taking as a relative example. In Python, you don't make statements, or in any programming language, you don't make statements that just has a subject, verb, and an object, but they usually have a if and then conditions that what you should be doing. So let's take a quick example. If let's say something simple as if A is greater than B, assign 2 to A and 4 to B. So I'll repeat that. If A is greater than B, assign 2 to A and 4 to B. Simple, isn't it? So let's take a look at these two statements, and we'll learn about what we're going to build. So here on the screen we have version 1, which says if A is greater than B. It translates everything what I just said into syntactical code, and it says if A is greater than B, A is equal to 2 and B is equal to 4. Now notice there is a parenthesis right after if, and there is a curly bracket that opens, and then there is A is equal to 2 and a semicolon, and B is equal to 4 and a semicolon, and then there is a closing curly bracket. Now this is in how you might have seen in other languages if you're coming from any other language, and this is definitely not how it's in Python. So how is it in Python? So this second visual that talks about how it's in Python. And the same thing, if A is greater than B, and there's a colon, and A is equal to 2 and B is equal to 4. And that's what we're talking about in Python. So you'll notice that Python is so less cluttered and so much more readable than the first version. Now how does Python manage this? It's very important for us to understand how does this become so simple, so readable. So let's walk through the main differences, right? Python gets rid of that the curved brackets and the curly brackets. Now how does it do that? But it has something else in its place if you have not noticed. Now let's have the visual back again on the screen, and now you can see that the curly brackets are gone, the curvy brackets are gone, and that means there is something else in between. Notice there is a colon and there is a white space, right? The statement is ended with a colon. The moment you put a colon, that Python will understand that you've ended a statement instead of the curly brackets and the flower brackets and the semicolons, and the white space is used, which is also called as indentation, to describe what takes place in the case of the statement. This is really important. And another major difference is a lack of semicolon in Python. So the moment you hit return, Python understands that you end that line. In other languages, semicolon is used so that you can identify, or you tell the compiler that there is an end of line. The line ends when you put that semicolon. But in Python, the moment you hit the return key on your keyboard and you move on to the next line, you're telling compiler the same exact thing. So in Python, the end of a line is the same as end of a statement. And lastly, to end this brief overview of differences, let's take a look at the indentation syntax in Python versus other languages. So here is some pseudocode to indicate the use of whitespace and indentation in Python. Let's look at this. If x and they do something, if y, then code statement, else there's some another code statement, right? And then you note those brackets and note those semicolons and note those indentation between the two ifs, and the else is usually right under the first if, and that's how you tell the compiler that your loop of statements ends there, right? So in Python it is something similar. You still have the if right below the else, but only difference is it's got no brackets. It's simple, straightforward. If x colon, if y colon, then you have a code statement, else another code statement. So it's heavily driven by code indentation and whitespace. That makes Python readability, and readability has always been a core part of the design of Python language. You take Python to any framework like Django or Flask or anything, you will see this indentation being carried out all through. So it's also very important. It's very simplistic, but sometimes we may miss this out and run into problems. But don't worry, I got this figured out. I will make mistakes in advance so you don't make them, or when you do, you know how to go fix it. So this is also a part of being a developer, being a programmer, is to as much as time you spend in coding, double that you would be spending in understanding how to debug or how to fix something that's broken. And that's a part of the job. Now let's start diving deeper by coding some of these statements in Python, and it's time to code. But just before we do that, there's one last thing I'd like to say, that about if, elif, and else. These are the three statements that we will be heavily using in Python. And there is something that I want to talk about it before we get there, so that it is ingrained in you, and this is something you will not forget. And I want you to go back to this example every time you run into a situation where you're confused, so you can pull yourself out of it. So normally when you have to remember something, you can refer to patterns or colors or objects, and that way, or examples, and that way our brain remembers something, and then you build on it, give it more experiences, so your dependency on those examples usually fade away. So there is this exercise, something I want to put you, so that just hear me out, and this I believe will help you remember what we are talking about, especially the statements part. We know that if statements in Python allows us to tell the computer to perform some actions based on certain set of results or conditions. Now verbally, let's imagine we're not coding. We have a computer that listens to what we say and does everything. You don't have to write a line of code. So let's say I'm talking to a computer. I'm talking to this computer, and I'm going to imagine that. So, and I'm telling the computer to do something. So let's say, hey computer, if this case happens, you perform this action, right? And that's one of the statement. Now I can expand this idea further with elif and else statements, right? Hear me out. Hey computer, if this case happens, perform some action, else if another case happens, perform another action. If nothing happens, then perform this action. So it's something like that, right? Let's go ahead and look at the syntax on the screen here for the format of statements. So we just exactly did that one right now. So there is if case 1 is to perform action 1, and if case 2 perform action 2, else perform action 3. That is how your computer will perceive what you just said. It divides it into cases and actions, and then else, when it finds else, it understands that that's the last part of the action, that when no options are available, that's the worst case scenario that I have to perform this, and that's what it would, right? Let's see a quick example of this, and let's make sure you code with me on this, and we'll go together. I'm switching over to my computer now, and let's start some code. Great, I have my Jupyter Notebook open and let's continue. I hope you're enjoying working on Jupyter Notebook. My first example, let's just translate what I just said. I'm going to say if case 1 is true, all right, and then I would say print it was true, all right. So let's see what this should ideally print, because I've set it to be true and it will continuously put true. Now let's add in some logic. Okay, so I'm going to say I will expand this. Okay, so let's make it more interesting. So I'll say x is set to false. All right, so I'm then going to say if x, see the way I'm coding, so the moment I hit return, it puts my there's a tab here. That's the indentation that Jupyter does. Whatever IDE you might be using, if you have a Python package installed, it will be very easy for you to do this. Otherwise, you just hit a double tab and that will bring you here. Okay, and then I would say print x was true, right? And let's say else print, very simple example, I will be printed in any case where x is not true. So what do you think this should print? Because x is set to false, so x is not true, right? If x is something, so it will print something. So you can take a guess, and I'm going to run this command, and you guessed it right. It's because we've set it to false, it will use the worst case, the last option. It will print when it's not true. So let's get a fuller picture of how far we can go, and I only have 2 conditions. What if I had 3 conditions? And let's see how far this can take us. We write this out in a nested structure, and do take a note of how if, elif and else line up in the code. Now this can help you see what if is related to what elif or else statements. Now let's introduce ourselves to a comparison syntax of Python. Okay. So I'm going to say that I'm writing a program, and that will ask me where am I, or ask me the location, and it just gives me a welcome. So if I say I'm at a bank, it will tell me welcome to bank. If I say I'm at a auto shop or a grocery store, it will tell me welcome to your grocery store. If nothing is there, I don't know, it should ask me where are you. So let's write that program real quick. So I'm going to say location, and I will say location is a string, and let's say first let's set it to something like this. And now if location is equal, and I say equal is double sign to grocery store, right, and then a colon, then I would say print welcome to the grocery store, right, and then else, or in this case let's go on, add more. Location is equal to, let's say, a bank, and then print welcome to the bank. And if nothing is there, else we'll say print where are you. Okay, let's have some fun with this and see what this does. So we've set bank, and no brainer what this will print. It will tell you welcome to the bank. Correct, you guessed it right. Now I want to change this to grocery store, and let's see what this will be. It will be welcome to the grocery store. Now I don't put anything. Okay, I put something else here, or I leave it blank. Now it should ask me where are you. So note how the nested statements are checked until a true boolean. So what exactly happened here? When I put anything here, it was Python is validating against every value to be true, and print only when something is true. When I put this as something else here, it will compare something else with grocery store. If the return is false, it will move on to the next condition. It will compare it with the bank, and when it is wrong, it will move on to the next condition. And then finally, when nothing works, well, it doesn't matter whether it is true or false. In this case, it is true, because we are telling that if anything else you don't understand, ask the person where are you. So it pops that question out. So you can put in as many as elif statements as you want before you close off with an else. Let's create two more examples with very simple if, elif, and else, so we understand this example really well. So I'm going to say create another variable called human, and I'm going to say and give it a name, and then if human is identified as John, right, then it says I miss the indentation, it takes me, I miss the colon, it takes me back to this, and when I put this, the compiler understands I need to be placing the cursor here with an indentation. Welcome John, all right, and then I would say else print hello, welcome, what is your name, like something like that, all right. Oops. Now let's execute this because this is John, it's printing John, and I'm going to say James. It doesn't know how to handle James, it will ask me hello, welcome, what's your name. So that's how simple it is, and I can let's copy a whole thing again, and I can put in a elif. Let's add what if it knew what it is. So elif human is equal to, right, and I will put this as James, right. So now system can recognize James, and then let's see what this will be. Okay, there is something wrong with this because I have not put a colon and then I have not set up anything. So notice how eager we become when we have to say when we have to move on. So just be wary of that habit, and it says welcome James. Great. So now you know how to work on if and else and elif statements, and it's very important to keep a good understanding of how indentation works in Python. This is very important. It does that because it needs to maintain a structure. We'll touch upon this a lot later, but right now we're building blocks of how important it is of colon, white space, I'm referring to the indentation, and how to structure it. And you may have noticed I made a syntax error and it gave you that error. All right, so let's move on to the next lesson. See you in the next class. In this session, we'll be talking about for and while loops. We'll essentially be understanding what loops are, when to use it, why to use it. Let's begin with understanding what for loops are. For loops acts as an iterator in Python. It goes through items that are in a sequence or any other iterable item. So for example, there are objects that we learned that we can iterate over, include strings, lists, and tuples, and we even built in iterables for dictionaries such as keys or values and so on. So we've already seen that how for statement works a little bit in the past. I just introduced you to for loops at a very bare minimum understanding, and how it could save a lot of time to repetitively go about writing something. It was so easy to use for loops to iterate over lines during files. It was so easy to iterate over in dictionaries, and same thing in lists, and when we did the list comprehension. So it's very easy to use for loops. So in general, as an understanding, we use for loops when we are iterating over multiple. The reason it's called a loop because it cycles again and again until your condition is met. Until your condition is true, it keeps going on. So those are something, that's why it's called a loop. And let's just look at the format of for loop. For loop item in object colon, that's how it is, and then there will be statements to do stuff. And the important part in this is keyword for, and then the keyword in, and then the object that you're referring to. An object could be a simple variable, it could be a list, it could be a tuple, it could be of any variable type, it could even be a file or a function, because everything in Python is treated as an object, and that makes it a whole lot interesting, right? And the variable name used for the item is completely up to the coder. So you can use your best judgment to choose a name that makes sense to you, and you also keep in mind it makes sense to someone else will read when they go over their code or your code that you're going to write. And if let's say you're trying to write something where you're talking about cars, you don't want to name something a movie star in that code, because somebody will not understand what let's say you name it Tom Hanks. People will not be able to understand when someone else is going over your code. When you're going to make car references to objects, if suddenly Tom Hanks walks in, they don't understand it. But this item name can be referenced inside your loop, for example, if you wanted to use if statements to perform checks. So I will give you some examples and share some best practices along the way. So let's go ahead and work through some examples for loops, and we'll also come back to while loops right after that, and then we'll see more about using loops as we go deeper in programming. So we'll start simple and build more complexity with loops. Let's get started. I'm going to switch over to my Jupyter notebook. All right, now let's try to see how we can iterate over a list. Okay, so I'm going to create a list. I'm just choosing list because it's very straightforward. It's mutable and you can write onto it. So I'm going to say this is my list, and I also have 10. Great. So that's my list. Now how do I print all the numbers of this list? So if I have to say print, or I just have to say, if I have to print this, I'll have to do this, and then it will print 1, and then I'll have to do this. If I have to print number 2, I'll have to do this. If I have to print number 3, and so on, right? So this is how hard it is. It can get. Look at that, I already made a mistake. So it can be really hard and tedious to print every number in the list. So for loop hence comes handy in these cases. When you're iterating over multiple objects of a Python element, then this is where we do. So it's for every number in L, okay, print number. Now when I do this, it prints, okay, so what am I missing here? You can see I'm missing a major important thing here, and this prints the parenthesis, and this prints 1 to 10 this way. So it saved me from indexing every element inside, but it went over a loop of doing this same thing, and it printed what I exactly wanted. Now that's what is the power of for loops. I can put anything here. I can call this a Ferrari. Oh, let me just take something else so I don't get confused with that. I'm going to call it Italy, for example. I can call this Italy. It has got nothing to do with, no reference. All right, I can call this anything I want. It would still do the same thing. Let me show you this. Okay, I'm going to rerun this, and it still does this. The green things in Jupyter is what is important, right? And the object name, which is our variable name L. Apart from that, what you write here is gibberish. It's ignored, as it understands that it's not gibberish, it's an important thing. So I'm going to call it number. I want to be decent and be readable, and also to be known for by reputation that I write clean code. It's very important, and I'm going to keep it number, and Python understands that you're referring to the elements inside that list. Great. I hope this makes sense. Now let's add a if statement to check for even numbers. But let me introduce you to a concept called modulo. Modulo is a remainder. So if I divide, let's say 3 divided by 2, the remainder will be 1, right? Or if let's say I'm going to divide 17 divided by 4, and the remainder will be 1. If I change it to 5, the remainder will be 2. If I change it to 6, the remainder will be 5. Let's see some more examples just so we get this right. So 10 divided by 3 is 1, because 3 times 3 will be 9, and 10 minus 9 is 1, correct? And I hope you are with me on this. Let me give you more examples just in case you're forgetting. What happens if I do 4 divided by 2? There won't be no remainder, right? So I'm going to do 4 divided by 2. Yes, there is no remainder. There is a 0, correct? So do some more of this so we know that we don't get confused this with anything else. It's actually the remainder that is there, and it will not continuously divide. So, and only when the number is fully divisible with known remainder, the result of the modulo call is 0. Now we can use this to test for even numbers, since if a number modulo 2 is equal to 0, that means it is an even number. Now let's get back to for loops, and I'm going to print and see if we can use for loops to print only the even numbers from our list. Let's print our list first so we don't forget. Great, so it's got 1 to 10, and I want to print only the even numbers. So that means I need to print only those numbers that are whose remainder is going to be equal to 0. So it makes it very easy if I put it that way. So let me show you how. So for every number in my object L, if number is all the numbers when divided by 2 are equal to 0, then I want you to, I need you to print the number, right? So if that number in my list is when divided by 2, the remainder will be 0. When this condition is true, print that number. So this is what it will do. It will print all of that. Now we could also put this in else statement, right? I can also put something more. So what about the other numbers? They are not printed. So let's put something about it. Let's say else print this is a odd number, right? So whenever it runs through the loop, it will take 1 in the list and it will divide by 2, and it will take the outcome and compare it, is that remainder equal to 0, and it will return a false, so it will not print that number. In this case, it will move on to the else statement. When 1 divided by 2 is not equal to 0, it will say print this is a odd number. Great, so that's what it will do in this case. So it will print odd number whenever there is a odd number, and then it will print 2. Now that makes it very easy, right? So if I have to print an odd number, I just have to change this, right? I just have to change this. When this is not equal to 0, this will print only the odd numbers. So if somebody in any interview asks you, this is a very common thing that they ask you to understand your for loops that print prime numbers or Fibonacci series or even numbers and odd numbers, and this is how you do it in one go. And anything else would be considered that you don't have enough experience in Python, and this is how you do it with just a few lines of code. Now, another common idea during a for loop is keeping some sort of running tally during multiple loops. For example, let's create a sum, something that sums up a list. So I'm going to say, oops, I'm on this tab. Okay, so I'm going to say sum, my sum is equal to 0. Now I'm going to say for every number in the list, my sum is equal to my sum. Oops, I'm going to assign my sum plus the number that is there. So I can keep a tally of whatever is happening, and then I would say, okay, all right, now I have my condition. I want you to print what you have. All right, so print my sum. So this should, let's say it will begin with 0. My sum is set at 0, and it starts at 0, and it will go all the way to from 1 to 10 in my list L, and it will keep on performing. It will take my sum, it will take 0, it will take 0 plus 1, and it will take 1, the value of this will become 1, and it will take 1, and it will go with 1 plus 2, and so on. So it will add all the 1 plus 2 plus 3 plus 4, and if someone tells you to add all the numbers in a list, this is how you do it. Right, read over the above cell once again and you understand what is fully going on. Also, we could have implemented something like this in one go. So let me show you. You can further shorten this by putting something like this, by putting just a plus here, and then it does the same thing, but it's doing a little extra. I'm going to just have to take this off, right? And I made a mistake, and now it's giving you the same result now. Great. Now we've used for loops with lists. How about what happens if we use with strings? Remember that strings also have a sequence, and we can iterate through them, and then we'll be able to access each of them in a string, correct? So I'm going to do that for letter in this is a string, for example, or I'm going to take something more. I am a fan of Avengers. Let's say I like Captain America. Just something to put there, and I'm going to say print letter. So this will just print all the letters in that, and again I made that mistake of parenthesis. By now you know what can happen, and I'm sure if we were in a live class you would be the first to point out. Now what happens if we do this for loop in a tuple, right? So I'm going to call a tuple, I'm just going to name it G, and just some random number, it's got nothing to do, and it's got 5 digits in it. Now what I can do with this is for every something in my tuple, print that something. I can put anything I want. I'll tell you this is not right, so I'm going to make it for every t in t, or I can say for every item in item, whatever, it's all the same, right? And some more examples to follow. So there is a special quality that I want to introduce you to, where especially when you're iterating through a sequence that contains tuples, the item can actually be the tuple itself. Now this is called tuple unpacking. Now during for loop we'll be unpacking tuple inside of a sequence, and especially if you run into a situation where you are returning this value in a JSON format and you recognize it's a tuple, and that's when we unpack that and sort of break it down to extract data out of it. We'll be using them in use cases later on, and let's say this is a tuple, and then I have, and this is a list of tuples, right? And some sort of values I have. I'm going to say 55, 44. All right. So this is my variable, and then I'm going to say for every item, I can even say element to make it easier, in my list, right? Print my element. So this is how it prints them, and notice how it's out of that list and it's broken down. Now I can unpack this, okay? So I can do this for T1, T2 in my list, print, I can only print just the T1, and this will print 2, 6 and 55, and if I print T2, it prints everything. And it doesn't matter what you call it. You can call it you can call it I don't know what you want to call it. Okay, let's call it Obama 1, and I can call it Obama 2. It doesn't matter. Python doesn't mind you at all, and it just prints the same result. So this, what is in the parenthesis, is understood as you're referring to the elements inside the tuple. If let's say there were 3, then there were 3 elements in this tuple, we would have 3 elements here, and we would identify it by we're declaring Obama 1 is the first element, Obama 2 is the second element, and if there was something 3, we would call it, and then it would print whatever we tell them. So that's how sequence works. We can access items inside them through unpacking, and the reason this is important because many objects will deliver their iterables through tuples. Cool. So with tuples in a sequence, now we can access the items of them inside through unpacking. Now the reason this is important because many objects will deliver their iterables through tuples. Let's start exploring iteration through dictionaries to explore this further. So we've tried this on lists and strings and tuples. Why leave dictionaries alone? So let's bring it on and see another example. I'm going to create some space on my screen. So okay, great. Now I will take a dictionary that from our previous session which we created, and I have key 1 assigned with value 1. I have a key 2 assigned with value 2, I have key 3 with value 3. Let's say this is our dictionary. Now if I want to iterate over it, so I would just say I would iterate over it for every item in my dictionary, print item. So it will print all that is there in it. Okay, this is not defined because I did not execute this. Great. So that's how it prints all the keys, and you can also print the values. And I want you to try printing the values on your own, and then let me know how it came through. I want you to try this as an example, and let me know how it goes. So we just need to do it something like this for k and v in items. So I'm going to say, look at this, I'm using a method. This is Python 3 special, and I will call upon the object, and I will use a built-in method by putting dot. And when I do a dot and hit tab on Jupyter, it gives me certain methods, right? As you can see, there are certain methods. So you just can't put a dot and hit tab, you will not get it. You need to put a dot after your dictionary. So in this case, it understands it's a dictionary, and it will give you a list of methods that you can perform. That's why Jupyter Notebook is so good, and I'm recommending this to you. In this case, we can do keys, we can pop, we can update, we can set default, we can clear the entire dictionary, we can copy it, and we can do something from the keys, get something. So we'll use items, and I'm going to show you how to use this. And I will put like this, and I can say print only the keys and stop just at that, or I can also say print only the keys, so stop just at that, or I can also say print even the values. So this could be anything again, this could be anything, this could be anything. I'm just addressing something so it becomes more readable, and that's how you print all the keys and values. Now let's conclude what we just discussed. All right, we've learned how to use for loops to iterate through tuples, lists, strings, and dictionaries. And it's a very important tool, and make sure you know this well, understood all the above examples. And once again, unless you try this on your own, you would not have learned it. It doesn't matter how much of an expert you are. I'm not saying it because of personal gratification, but it really does make sense if you spend time with it. The more time you give it, the better you become at this. See you in the next class. Now, in this section, we'll be talking about while loops. I hope the learning is coming really good, and I believe you understand for loops well. And if not, please do go back and try some of those out. Do ask any questions that you may have. Feel free to write to us or post your comments, and so that we will be able to answer them for you. Let's move on in understanding while loops. While loop is also a part of Python statements, and it's one of the most general ways to perform iteration. In some form, while loops are dangerous because I'll explain to you why. And coming back, a while loop or a while statement rather will repeatedly execute a single statement or a group of statements as long as the condition is true. The reason it's called loop is, again, because the code statements are looped through over and over again until the condition is met. Now, here is a general format of what while loop is. While you're doing something, there's a code statement, else the final code statement. While is called a statement because it's used with the if, the else, or the elif statements. Let's look at a few examples or few simple while loops in action. I'm going to switch over and to Jupyter Notebooks, and let's start some coding. Great, I'm on my Jupyter Notebook, and we got to learn about loops. I'm going to call while loops, and we will name the notebook and save it. Now let's start with something simple as what we did last time. I'm going to call x is equal to 0, for example, and then I'll say while x is less than 10, then print that x is currently something. Okay, let's say like this, and I will print this as x. Okay, now let's say print x is still less than 10, adding 1 to x, right, and I will perform a assignment and an addition. So, this is an addition and an assignment operation 1. So, until x is less than 10, I want a 1 to be incremented to my variable, and the variable should be value should be changed until the x becomes less than 10, until as long as x is less than 10. So, there you go. So, it should ideally print from 10 times from 0 to 9 and keep on adding until the last condition is met, right. So, notice how many times once again, if you like to see how the while loop kept going, kept looking until the true condition was met, which occurred once x became equal to 10. It is important that we note this occurred and the code stopped. Now, let us see if we add a else statement and what happens. And so, I will take the same thing and I will add a else statement. Great, something like this. All right, let's see what happens. And the last one will be after it has completed. Right. So, this is how it works, and there is also something called as break, continue, and pass. Now, we can use break, we can use continue and pass statements in our loops and add additional functionality for various cases. And here is a visual of how that works. And now, on your screen you can see that breaks out of the current closest and closing loop, continue goes to the loop of the closest and closing loop, and pass just passes it on and does nothing. So, let us think about how we can use break and continue statements. Let us say it is something that gives you to use multiple if statements within a while statement, as we show it in the visual there, and the continue also can help you add more functionality as much as break does. So, break and continue can appear anywhere within your loop, but we usually put them further nested in conjunction with the if statement. So, it is more appropriate, more useful, and we feel more in control and helps us perform an action based on the same condition. So, we do not deviate from our original condition, and so we couple break and continue with the if and else statement, or sometimes with just a if. Let us go ahead and look more examples in my screen, and let us go back to our same example. I am just going to copy the same thing until we have this. Okay, and all right. So, I am going to add a if column here. Oops, if x is equal to 3, then print x has now become equal to 3. Let us just make it more useful, 3. All right, great. So, I hope you are with me on this, and I will say else print I am continuing, right. So, until x is equal to 3 it prints, and after that it continues. I am moving on and I am going to I'm continuing. I think that makes sense. Let us add more appeal to this, and then I would add a continue. Okay, let us see what happens if I run this. Right, it has gone all the way to 10 and it will keep on continuing. It does not end at else. The reason I added continue, see what happens if you remove continue, or if you remove else, see what happens, just remove else and have only continue, check what happens when you have else. I'll leave that to you for experimenting, but you can notice that it printed 3. After 3, it ran a loop only between the else, right? It would come, x is already 3, okay, then what should I do? Print, I'm moving on, continuing, and then continue. When you say continue, it puts Python back to the first line of code and execute all the way from the beginning, and that's what continue does. Let's see what break does, right? So I'm going to take the same thing and going to use the same code because it's a pretty relevant example, and now that we've already gotten deep into understanding how this works, I will add a break here and see what happens. Okay, just for the heck of it. And when you say break, it once this condition is met, it stops. It does not continue after that. So break will break what you want to do, and how it did not, and how the statement did not go to else, and continuing never happened. Now, after these short examples, you should be really comfortable in using statements in your code. Just a word of example, if you don't have a proper validating statement, I'm going to write an example. Okay, if x is equal to true, or let's make it something, while true, print this crashed my browser, took me to infinite loop. I would recommend not to try this, but if you're in an experimentation mode, go ahead, run it. It's just a browser. Make sure you have your favorite tabs and everything saved. Your chat windows are closed on your if you have anything on your browser, and so you don't have anything important, because if you run this will crash your browser. So that because it takes you to an infinite loop, because the condition is always true. There's nothing to validate against. There is no end to this. Great. And I now believe you have a good hold of understanding statements, understanding for loops, while loops, understanding how break and continue works. And this is the fundamental of Python, and you have made it this far. You can now go about and create a lot of programs. You can automate anything with just this. We haven't even begun to learn programming, but we know so much already. The next up, we'll be talking about something more in Python, and after that I will spend some time to show you all the powerful things you can do with Python with just about what you've learned so far. And all of this should make you enjoy. I know it might be really tough at sometimes when you take on coding yourself. For that, I will give you frameworks as we go through the course, so you will be able to decipher and dissect problems and break them down to be able to solve them. And that potential, when we get that basics right, you can go about becoming a great developer yourself and learn not just Python, any language that may come in decades to come. So I wish you all the best, and keep the same focus, keep going. See you in the next class. Excellent. We've already seen a few examples of what we're going to learn, and what we're going to learn is called methods. When we were learning about object and data structure types in Python, like lists and strings, we've come across methods like append, upper, pop, and a lot more we've seen over the different videos. Methods are essentially functions that are built into the object itself. So they are built into whatever object you create, and there are some inbuilt methods as well. So we'll learn about how to create our own objects later on using object-oriented programming and classes. But this particular section, let's go over methods and clearly understand, so we don't get confused with methods and functions. Methods actually perform specific actions on object, and they can also take arguments just like a function. And this is a brief introduction and get you thinking about all the design methods that we touch back upon when we are going to learn about object-oriented programming in this course. So we're setting you up putting you in a good situation to be able to comprehend and digest and implement object-oriented programming as an expert in your path of becoming a cool developer or a programmer or whatever your intentions are to be a data scientist or an analyst and so on. And methods, let me just give you an example on the screen of how the method looks. So a method is always dependent on an object. So there is an object and there is a period or a dot, and then there is a method and there are some arguments. Now that's the very brief view to understand how methods work. You later see that we can think of methods as having an argument as self. Okay, remember this keyword called self. I will put this on the screen as well. Self is a keyword which refers to the object itself. We will be using this and more so heavily in Django and Flask, in other words, but you understand we are learning methods and the self right now in the foundation, and you can build on this learning so on. Now, why are we using the self and why are we referring to the object itself? We'll see that. That is because if I have to just define it, we'll be using it during an object-oriented programming course. I want to still be introduce you to something what a list has got as a various method. Just go over it. So now we went over certain methods. I will put them up on the screen as well. And the method that we tried during list, I want you to try out. Create a list and give it a value from 1 to 10, okay, and try this as an exercise, and then try out all of the methods starting with append, count, extend, insert, pop, remove, reverse, and sort. Try all of these methods and let me know how that goes. Now those are inbuilt methods. So don't forget to try them and play around with the rest of the methods. And I also will recommend you to Google search for methods from the Python documentation, and then you understand how this is, how methods work. And by this lecture, you feel comfortable calling methods for objects in Python. And let's move on to learn something more important before we jump on to object-oriented programming. See you in the next class. Great. I hope you've been learning a lot of Python and having fun learning. And in this session, we'll be learning about functions. And there is a assignment right after this, a sort of a homework that I really recommend you to go about trying it. Great. So let's come back. In this session, we're going to talk about functions. Like I said, what are functions? We've been talking so much about it, methods and functions, and what is all this we're doing. Functions, if you're coming from a different language, it's fairly simple. And they are one of the main building blocks when we construct a lot of amount of code. Let's define function formally. It's something that it sort of groups everything together. It could be a group of statements together, it could be a group of operations together, and it could be run more than once within a program. And they also let us specify parameters that can serve as inputs to functions. So for me to process somebody's salary, I have written a function that does some sort of computation and tells me how much tax I have to pay, for example. Then the input could be the salary, right? I need to pass that value into my function. On a more fundamental level, functions allow us not to have repeatedly write the code. So if I have to process the function for one employee, I mean process the salary for one employee, I have a certain operations to perform. But what if I have 1,000 employees? Let's say I have 10,000 employees. Now how do I handle that? So I don't need to write this operation again and again in my code, but I write a function. So if you remember back on the lessons and strings and lists, remember we used a function called length to get the length of a string, because checking the length of a sequence is a common task. You want to write a function, and that can do this repeatedly at command at the time whenever you want it to be done. So that's where functions, and they become a very basic building block of reusing code in Python. And reusing code is another design feature of Python, so that you're not repeating yourself. And it will also allow you to start thinking about programming design, which we will dive a lot deeper into ideas of design, which is very important when we learn about object-oriented programming and object-oriented design. Now, let's see how to build out a function syntax in Python, and let's get started with a piece of code and see in our hands-on. To begin with, let's keep it very simple and build on, add more complexity, and like we always do. All right, over to my screen now. Great. Let's see how to write a function first. So function needs to be defined first. So we have a keyword for that. It's defined, pretty obvious, right? And then we have a name of function, and that's something you put, and then we put an argument 1, and then maybe an argument 2, maybe more, it depends, and then you have some sort of code. I'm going to put 3 ticks here. This is called a tick, or you can also do something like this, and this is a place where you write your functions document string. We'll get to this in a bit, and then after that you sort of define what you do here and return something, or return a result. That's what pretty much it does. So we begin with the def and a space followed by the name of the function, and then we try to keep the names relevant. For example, length is a good example for the length function, right? So instead of calling len, right, for example, instead of calling it length, we call it len. So we sort of keep the name relevant, and also you have to be really careful that there are some built-in function names. I cannot create another function with the same name of a function that is already built in Python. So I cannot create a def len because this is already a function. So here is a link that I am giving it to you so that you can reference this link, and always be sure that you're not using a function or naming a function with the same name as what is already built in Python. You will run into trouble if you do so. Nothing worse will happen. Your program will just not run the way you want it. That's about it. Then we have a pair of parentheses with a number of arguments separated by a comma, and these arguments are inputs for your function. You'll be able to use these inputs in your function and reference them. After this, you put a colon. Then now here is an important step, right? You need to indent to begin the code inside your function currently. If you miss that indent, if you miss this tab, so everything after the function should be on the same line as this, not everything, but pretty much the next line. And if you miss this, then your function will not be running correctly. So Python makes use of this white space to organize your code. A lot of other programming languages may not do this. So if you're coming from another language, you think that's flexibility, so that you can type anything at any line, but that's not flexibility. That's making code unreadable. So much so has gone into Python. If it's easier to type and easier to understand, it should also be easier to read. I know it might be harder to program. That's a whole different argument to have separately. I'd be happy to catch up with you on that another time. But it's so important that we indent, make it readable all the time. And Python swears by it, and it's at the core of it. Now, what is this doc string I mentioned at the top? This is the doc string I was referring to. This is where you write a basic description of the function. So this is another really cool thing of Python. It lets you tell people, let's say you've written a program, it's got about 6,000-7,000 lines, and then you have several hundred functions, and someone else takes over, or you have to move on, you got promoted and you need to do something else, and someone else has to work on, you need to hand off your code to that person. How would you go over 300 functions that you've written a year ago? So this simplifies this. It's not exactly for that, but again, readability is at the core of it. So there is a doc string, and that comes across a function. Every time you press Shift Tab after a function name, you'll be able to see or read these doc strings. They're not necessary for simple functions, but it's a really good practice to put them in, so you or other people, like I said, be able to read this. And after all this, you can begin writing the code that you want to implement. Now, What's the best way to learn functions? Well, there is no simple easy route. It's through examples. It's through trying to go through examples and relate back to various other objects and data structures we learned before. We may not be able to try a function or there's never an end to writing functions for all different types, but let's go over some examples we humanly can. I'm going to write a simple function. Okay, so it says this one, the job of this function is to say hello every time this is run, and it just executes this. Okay, and I will put this 6 again and says this just says hello all the time, or make it more relevant, hello every time it's called. Okay, now that we have the function written, we need to call the function. What do you mean by calling a function? It's just nothing. You just have to type this function and run this, and it says hello. And I'm going to write another function which will be the greeting. Let's call it a greeting, and I want to this time address the name of that person, name of person. Okay, and I would say print. Okay, print. In this I would say hello. I will talk about this modulo s in a bit, and then there is a modulo name of person. Right, so that means this function takes an argument and then says hello and then passes or returns that argument, right. So it's not exactly the return call, but we can officially say so. And greeting, it says I'm going to call as usual, we're going to call upon James Bond. Now notice that I haven't defined a type of argument that it should take. Normally we do, but let's say I run this, it says hello and James Bond. If I say greeting and say 1.4, it would also still take that because we haven't really handled it. We look at handling exceptions and so on later on. I was talking about return statement, right. So let's see some examples that use a return statement. What exactly is a return statement? Return allows a function to return a result that can be stored as a variable or used in whatever manner a user wants. Let's create a function that adds numbers. Okay, so I'm going to create a function that adds numbers. Okay, so it takes, of course, I cannot add with only one number. I will need two numbers to add, right? And I want it to return a value which will be an addition or sum of num1 and number2. That's all return does. Now if I say adds numbers and I pass on something, okay, something like this, and this adds it up, or let's keep it more simple, adds numbers 1 and 2, and this returns 1 plus 2 is 3. That's what it returns. And you can also save a variable due to a return. I can also say result of that add number. So result is a new variable I'm creating, and then I can, because I know what it returns will be a number, I can just run it like this, right? And then I print, okay, adds numbers. So I print result. I can do it either this, or I can also do this inside of the parenthesis, and this prints 4 plus 3 is 7. Now what happens if we put two strings? Here we saw I put number, it worked. You're talking about numbers and all that, and you have num1, num2. What exactly happens if I put strings? So it's simple. I say print, and I say adds numbers, and in this case I'm going to say string, let's say I'll add 6 with 7. So a trick question, what will be the output? 6 plus 7 is 13, right? It should output 13. Is that correct? And if you think so, it will be 13. No, it's wrong. You've got it wrong. So it's a string we're passing. So Python does not know you're talking about numbers. So oops, I have done something. I've made a grave mistake. what have we done here? So I used print, right, and it says adds numbers. So something I have done is incorrect. So it says invalid syntax because it does not accept that we are adding a or I can, if print is confusing you, if is what is happening, it adds it like this. So you cannot do print and this, but you can definitely do this, and it's added it as if they are numbers. So Python is still there. We don't declare variable types in Python. If you are in other language, you would say variable integer a is equal to, is equal to 4. You go about defining this sort of a thing in other languages, but in Python we don't declare variable types in Python. This function can be used to add numbers or sequences together. So that's how Python understands. So it did not add a string, it added a set of sequences because it did not get numbers or integers. So we'll later learn about adding in checks to make sure a user puts in the correct arguments in our errors and exception handling. But for now, I hope you are getting what I'm trying to say with respect to functions. Let's also start using break, continue, pass, and other elements in our code we introduced during the while loops lecture. And then we go over creating a function as an exercise so that it helps us to check whether a number is prime or not. So let's try that exercise. It's a great idea. Let's try and see if we can write a function that tells us whether a number is prime or not. All right. So how do you know what's a prime number? If you're heavily into mathematics, you would know it straight away. But for those like me who are not really math savvy, I don't know if that word really exists, but for those who really are not, mathematics is not their strength, you can Google. But since I've done this many times, I know a prime number is the one that is divisible by the same number. So for example, and there is no other number that can divide a 7, correct? So 7 can be divided only by 7. It's a prime number. So a number is called prime if that number is only evenly divisible by 1 and itself. So let's try to use this understanding and then be able to write a function. Okay. Let's begin with creating a function and check for prime is let's say check prime, and it'll take a number. All right, and then I will say a very beginner method of checking for primes. I'll put this, and after that I'll use the for loop for every number in range. Okay, be with me on this. You'll know as I type the code. For every number whose division, when they are divided by this number by itself and is not equal to 0, print. So that's what the function, right? So if it's divisible by itself, only then it will be 0. And I'm taking the same number and trying to divide it, and it will say not, this is not a prime number. All right, and it will break after that. Else print prime. So this is if it's not 0, if it's not equal to 0, then it's a prime number. You've got a prime. Okay, let's see this function in action. So I'm going to say check prime, and let's say I put some number. This is not a prime number because when it tries to take that number and tries to divide it by 2, and the result is not 0. So what happens if I check prime 11? You've got a prime. It's printing because it's trying to divide it many times, but that's fine. We can handle this later on. What if I put for 7? say you've got prime, and it prints 3 times because it continuously checks and iterates. So note how we break the code after the print statement when it's not a prime number, and how it prints continuously when it's not. And also we can disregard all the even numbers after checking for 2, and we'll also switch to return a boolean value to get an example of using return statements. Let's try to make it much more robust this time. I will import a library this time. We'll talk about libraries later on, but math is a library built in to perform mathematical operations, like there are mathematical methods. So this is a library is a set of functions, and it's got a lot of functions and methods inbuilt, and we're going to use one of them. I'll be sure to leave a trail of where you can actually watch this, read about all the math functions that is there, and then I'm going to use the same function that I have. So check for prime, and this time we'll take a number like last time, and then let's call this is a better method for checking primes. Okay. So let's see how that works. Well, you might say you're using the same method. Yeah, I need to still check whether it's evenly divisible by 2, and there are no remainders, and I want to add a boolean telling that whether that number is greater than 2. If either of it would return only when 2 of them are true. So otherwise it will return false. Okay. And then for every value element in my range, this time range starts from let's say 3, and I will be handling this with this time by specifying an integer math dot square root. This is a method, so I do a math dot and hit shift tab. It gives me whatever I have and how this actually works. So I'm going to use a method from library called square root number. Then I can add a plus 1 and 2. Okay. Now if that number is modulo I is equal to x is equal to 0, then return false, and if nothing happens, return true, and this should be at the end of it, right? So let's see what happens if this is a function, and I will call this function. Okay, check for prime, and we'll try the same number again. This time it's false. This is not a prime number, correct? And I will try to put another number, let's say, and it gives me an error. So we cannot multiply sequence of non-integer type. So I will look forward for you to resolve this, and you can let me know what is wrong in my code here. If you're able to pick this up, that's great. I'll pause for a while and see if you can answer this. So great. So what is a problem here is that it is considering that there is a number that is, well, it passes all the way. So this part of the code is correct. It's returning a false, but only after I write this here, that's where the problem is. So I'll try to let you guys solve this, and please watch out for a solution in the assignment. I'll leave this as it is, and please go about. If you understood this, you would solve it. Otherwise, please feel free to search. Great. Now you should have a basic understanding of how to create your own functions to save yourself from repeatedly writing code. Let's move on to understand some more core concepts in terms of object-oriented programming in Python. See you there. Great. In this session, we'll be talking about one of the most confusing and for beginners and something most used expressions called Lambda expressions, and that's very useful, and it helps us to create what we call anonymous functions, because we really don't need to define a function the way we do it while creating a function, but basically helps us create a ad hoc function without having to properly define using the def keyword like we saw in the previous session. So function objects returned by running Lambda expressions work exactly the same way as those created and assigned by defs. There is a key difference that makes Lambda useful in specialized roles. Then that's because Lambda's body is a single expression. It's not a block of statements, and it's not clogged with a lot of things. It maintains its name, and that's why it's called a Lambda expression, because it has only a single expression. Now the Lambda's body is similar to what we put in a def body's return statement, but we simply type the result as an expression instead of explicitly returning it. So you're not returning it, but you're actually typing it as an expression. I'll show you in an example. And also because it is limited to being an expression, a lambda is less general than a define of a function or a def that we call. So we can only squeeze design to limit program nesting, and now there is a special reason why we use lambda, as lambda is defined to handle or to code simple functions, and def is used to create larger tasks. So let's slowly sort of break this down, all of it, so we understand conceptually what this means, and so tomorrow if we have to explain it to someone else, you know what exactly to say. And let's go back to my screen and let's code some examples. Okay, now let's start looking at breaking down a Lambda expression, and let's start by deconstructing a function. Okay, so all right, I'm going to try to write a function that squares any number that I give it as input, or I pass it as a parameter. Okay, let's see how it's done. So I'm going to say define the word def keyword to create a function like we saw in the previous session, and square number, this converts everything to a square number. It takes some argument, and then the result will be equal to whatever the value has been passed, and it squares the number, right? And then after that it should print the result or return whatever the result is, the value of the result, correct? This is essentially our function. Very simple, isn't it? Now if I pass this, a call upon this function, okay, and then I pass on a value 2, like I have one argument, and this should return 4. Perfect. This is doing exactly what we wanted it to do. Now I'm going to continue the breakdown. Okay. So I will take the same function but not put the return statement. Let's see what this does. All right. So I'm going to still copy this, and I paste this, and this is not returning anything, right? So because I need to call that function, correct? There is no print, and I need to result, and now okay, there is something print. It says result is not defined. So what are we doing here? So I've created a function, and I'm going to create something different if you'd like to, if you think that there is a problem. And then there is something, I have a square number. Okay, I have to execute them. Perfect. So now there isn't anything that is coming out if I'm printing. So if I do something like this, print, and there is nothing, it says none, there's no outcome at all, because the result right now is where the value is held. And we can actually do all of this in one line, although it would be really bad to do so, but it's still, let's say what this happens. So I'm going to create a function called make square, okay, and then it takes a argument as usual, then it returns a number multiplied squared to 2, correct? So now I say make square, and then I put 4, it returns a 16. There is a return word. So this is the form of a function that Lambda expression intends to replicate. So let's look at a Lambda expression. How do we write one? So I just take Lambda and take number, and number multiplied by 2. So this says something to give you some sort of an error, right? So this is actually, we got a function back. That means we can assign this function to a label. So now I can take a new label. Let's say make a square, and then I take Lambda number divided by multiplied or exponentially multiplied by 2. And after that, I just have to say make a square, same way we did, and this returns whatever value you put in. And there you have it, the breakdown of a function into Lambda expression. And that's about Lambda expression. You can try out some more examples. Try to write a Lambda function that will give you an even number. So a hint for you is to try out how, when you take a number and divide it by 2, if the remainder is not equal to 0, or it's an odd number and the remainder is equal to 0, is an even number. So in this exercise, try to create a Lambda function, give it whatever name you like that makes sense to you, and it should take a value and tell you whether the number, a given number, is a even number by true or false. Okay, you try that. I'll pause a bit and then I'll show you how it's done. Okay, continuing Lambda expressions. Now I gave you an exercise to print whether a given number is even in terms of true or false, and I hope you were able to write that Lambda function. If not, let me show you here in my Jupyter notebook, and let's try to decipher this. So I'm going to say even, check even number. I'm just going to check even. It's pretty easier that way, and I'll use the Lambda word, and then I create a Lambda expression that verifies whether that number is divided by 2, returns a value of 0 or not. So I do check even, and this returns a true. I do check even, and it returns a false. So very well. So that's how you do it. And we can also do Lambda with strings. So I'm going to create another Lambda which grabs the first character of a string. And you can, let's say you're writing a program, and in that you have scraped a website which has a lot of text, let's say Wikipedia, you need some articles. In that you want to grab the first letter of all that is there in a paragraph. I don't know, just want to do it for some reason. I'm trying to find a use case, but it's hard. But let's say you have some words you want to find, you can also do so this way. Then I call it like this. So I'm calling it that I have some text. Let's say I can even call it text, and then text, but I'd rather call it something smaller so we can remember it. And there is a string of characters, and I want this to grab. So I haven't even written what it is, so I'm going to say first, and I will say something like this, and it grabs the first letter. So it's that simple. Imagine if you had to write a function for this, and so much of waste of lines and time you would have, and also memory, to be precise. So it's very simple, and you can do so by reversing a string also. Reverse a string, I create something, and then I will type the word Lambda, and I can call this something else this time, or let's call it the same. And then how do you reverse a string? If you remember, it is colon colon -1, and then I take this and I pass on some value, and let's put some really long name. I'm just trying to think of a, okay. Um, yeah, let's put some country name. I've got no references, nothing to do with this country. I just, because it's got a lot of characters, I just put one. I'm sure there are other examples. I'm just taking something that came to my mind and it reverses the country name that way. So it's simple, just like a normal function, this works. Now there's something else also it can do. It can also accept more than one function into a Lambda expression as long as we maintain a single expression. Let's try to do something like that. So till now we've been dealing with one um, element, right? There's x, there's only t. What if there was x and y? That's what I'm talking about. And I'm going to say add, adding, this is a adder. I'm writing a function that adds two numbers, similar to what we did in the previous exercise. And this takes, again, to add a number, I need two numbers. I need another number, right? And then I will perform the add operation. So x and y will be my numbers, and I will do a x plus y, and then I do pass my values, and this simply returns 2 plus 3. So great. I hope you had a good understanding of Lambda expressions. They really are useful when you use it with map, filter, or reduce. We'll be covering this in this same lecture, and each of those functions we're covering it separately, so you can explore them. And I also highly recommend reading more about Lambda functions. There are some really very interesting examples out there, and I hope you enjoy spending the next hour. I'd really highly recommend you spend the next hour writing functions and another hour working only on Lambda. That will sort of make you perfect. So if you're just watching this video and moving on to the next, I think it only makes you what everyone else does. But when you take your time and pause and practice, you're a few steps ahead of everyone else. And that's how you cover more ground and you make more progress. Although you're watching the video, watching video is slow. Trust me, I've watched a lot of videos, self-trained myself on a lot of languages. It's very important that you go steady and you can go the distance. And I hope you are coding along with me. And thanks for watching. See you in the next class. Now that we've gone over on writing our own functions, it's very important we understand how Python deals with variable names we assign. What exactly happens when you assign a variable name? And when you create this variable name, there is something you assign a value with it. Where does it get stored? And the place where it gets stored is called a namespace. Now, variable names also have what we call a scope. Now, the scope determines the visibility of that variable name and makes it available in other parts of your code. So, let's say you wrote a function, declared a variable, for example, and that variable is somewhere inside a function. Then you are writing another function. You cannot, get access to a variable that is within a function. So that's out of scope for that function, right? So I'll explain to you what I'm talking about, and then we'll come back and sort of analyze our situation in terms of where we are in understanding scope, in nested scope, and so on. So let's hop on to my Jupyter notebook here. Great. Now I'm going to create a simple variable here. So everything we are going to do about scope will be mostly understanding where we can call upon certain objects, whether within outside or inside of our functions. And it's very important to understand because you don't run into trouble and your code will execute if you understand this better. So I'm going to just say a function, and that will it just prints something, and it takes no argument, and it just says x is equal to 50 and return x. Notice I have two variables. Here I have x is equal to 25 outside of my function, and here I have x is equal to 50 inside of my function, right? So it's like this guy is publicly accessible and this guy is private. So let's say this is a coffee machine in a mall or a theater, and everyone can go push the button and get their coffee, and this is something inside your house and only you prefer to use it. So let's, and I can't make a better example than that. So this is outside the house and this is inside the house, that sort of a thing. And I'm going to print, write a print and say x. Let's see what this does, and I will print just prints. Okay, and let's see what this one does. So great. So this is printing 25 and this is printing 50, right? What do you imagine? What did you imagine when I wrote this, right? So what happens if I just call this again? What do you think will be the output? You know, would it think, oh, am I referring to the x here, or am I referring to the x here? You can guess this is going to be 25. Anything outside of this is here, and anything inside of this is here, and that's how Python sees it. So this is out of scope or in scope. So I'm going to just print this again just to be clear, and that prints 50. This is interesting, but how does Python know which x are we referring to? All right, I understand this, but how does Python know? Python uses where we call scope. This is where the idea of scope comes in. Python has a set of rules it follows to decide what variables, such as x in our case, that we are referencing in our code. Let's just break this down a bit more and see how these rules work. Now, this idea of scope in our code is very important to understand in our order to properly assign and call variable names. Now, in simple terms, idea of our scope can be described by, let's say, I think we can describe it in 3 general rules. We can sum it up that one is where we have or we name assignments that will create or change local names by default. So this is like, you know, whatever I name the assignments by default, it will either create or change local names. And then there are name references, like name references search for scopes. So there are 4 type of reference search Python does. This is a second rule. Every time you write a variable, Python looks for scope. Is it a local scope? Is it enclosing functions? Like this particular variable is enclosed in a function, so it's called enclosing function scope. Is it a global function? Like this is declared at the top, that means it's available throughout the program, it's called global. Or are we referring to anything built in? So that's the second rule. And then names declared in global and non-local statements map assigned names to enclosing module and function scopes. So let's see what we're talking about. There is something called as LEGB rule. So I'm coming to come that is that there is something called as local, for example, that are names assigned anyway within a function is local. So this particular variable is local to this function, correct? And this is not declared global in this function, correct? And then enclosing function locals. So name inside the local scope or any enclosing function from inner to outer. So this could be a function within a function, and it could be enclosed to be used only within that function, or like a def or a lambda. And then there is a global, which is also called a module, which are top level. At the top of your file you declare global, and you can always call upon this within a function. Then there is built-in functions like open, range, and syntax error and others, which are Python specific. So this is what we're talking about. Let's look at what is a local variable scope. So I'm going to create a function where I will say x is local, right? This is an example of a local function. The x is only available to this particular variable. Only when you call this you can use it. You cannot use this anywhere else. Let's look at an example where we're enclosing function locals. So this occurs when we are working on a function inside a function. So it's a function within a function. So let me declare a global variable and say this is a global name available to every function. All right, and now I'm going to create a function called say hello, and then I will write a enclosing function variable with the same name, say James Bond, right? And then I have another function within that function, greeting, and oops, I missed oh, okay, and then I have another, let's say this, I want to use the name, and I will say this like this, hello plus name, and I will call this in my program. I'm going to call the greeting. Oh man, okay, something's wrong with my keyboard, it's acting funny. Okay, and then I will at the end call hello. So notice I'm calling this within my function, I'm calling this outside, and the behavior, I don't know what's going to be. I'm really nervous what's going to happen, and it gave me an error. It says hello is not defined because it's say hello. Okay, great. So this did not do anything. What is it supposed to be doing? Because this is again indentation. It should be outside of this, right? It should be somewhere here, and I'm going to try this. It says hello. Okay, let's give it some space here, and I'm going to run this again. It says hello to James Bond. So that's how this works. This is a function within a function. It's called enclosing value. Notice that this has no reference whatsoever because we are making use of this particular variable and not this, right? What happens if I just say print name? This is calling the function, the variable outside of my function. So that's how it works. Luckily, there is a way to know what we call in Jupyter or built-in functions. For example, I type this, and it tells me this is a function, this is an inbuilt function, and you cannot override this. Great. So that's how functions work and scope works. Okay, let's look at another example. So when you declare variables, especially when we are talking about local variables inside a function definition, they are not related in any way to other variables with the same names used outside the function. In our case, this is a local function. It has no reference. It's got nothing to do with this variable outside of the function. Now, all variables have the scope of the block they are declared in starting from the point of definition of the name. Let me show you another example. So this time I'm going to declare a global variable 50, and I will create a function and I will call it function, and let's say it is supposed to print x is something like this, x is, and print out x, and I will define the value of x is equal to 2, and then say print changed local x to x, then I'll say function, I'll call that function, and then I will say print x is still x. There you go. So what is happening here? The first time that we print the value of the name x with the first line in the function body, Python uses the value of the parameter declared in the main block. So it's actually referring to, well, this is the first time, this is how it goes. So until this point of time, this function does not know about this variable, right? And Python uses the value of that parameter declared in the main block instead. It takes it from the global variable, and then we assign the value of x is equal to 2. The name x is local to our function. So when we change the value here, it actually printing this x to this. We are not changing the value by typing change local, we're just printing x. I can take this off, completely, and it will still print 2, and that's what it's printing. And after that, when we call upon, right, when we call the function, something interesting happens here. We display the value of x as defined in the main block, thereby confirming that it's actually unaffected by local assignment, and it still remains, it holds its value of 50, and that's what it does. So now if you want to assign a value to a name defined at the top of the program, then you're declaring a global variable. You have to tell Python that the name is not local, but it is global. So we do this by using a global statement. I will show it to you in an example. It's called global statement, and it is not possible to assign any value to a variable defined outside the function without that global statement. And we can use these values such as variables defined outside the function. However, this is not encouraged, so we should avoid doing things like defining outside of the function for a variable that we're going to use it inside the function, because it becomes really confusing to the reader of the program as to where the variable's definition is. So using the global statement makes it very clear that variable is defined in the outermost block. So this is how you can define it. So I'll take the same example, x is equal to 50. Okay. Now what if I have to declare a variable which is global, but I will declare it within a function, inside of the function? So that is done, like I said, using the global statement. I just type global x. Now whatever I do now, it will not change. This function, let's find out what happens rather than me telling it, is now has the values of global x. Okay, and now it says print, because of global x is, let's print the value of that, and then I'm going to change the value here. Let's say I'm going to change it x is equal to 2, print I ran function changed global x to this value. Now is when it changes, because we've actually changed it. Now let's see what happens if I print. I'm going to say before calling function x is, and I will call function, and then print value of x outside of function is, let's say some codes here like this, so makes it nice and easy to read when the output is printed. Right, x, name x is parameter and global. So that's what it's giving me a return. So what is it trying to tell me on line 4, 1, 2, 3, and line 4? It's just printing the value, right? So I have not actually printed anything there. Okay, let's see how do we troubleshoot this. And I'm going to do this, and it says still line 4, 1, 2, 3, 4. Okay, this is global x, and I'm defining x parameter is global. So it says what it's telling me. You know what? I should take this off. You see what I did? And it's not any problem here. Now this should just execute fine. So it just takes a while, and you can make any mistake, and it's completely okay. So before calling function, x is 50 at this stage, like you can see, and then we assign value to x inside the function. That change is reflected when we use the value of x in the main block. Now you can specify more than one global variable using the global statement inside of a function or outside of a function or anywhere you want, and Python will always be aware of the scope. As long as we keep a scope in mind, we should have no trouble declaring variables. Great. Now you should have a solid understanding of scope. You may have already intuitively felt right about scope, which is great. And you might have thought, yeah, that makes sense. Yeah, it's inside of the function. How the heck can I call it outside? And oh, it's outside of the function. Oh, I should be able to call it inside. But how do I declare my own variable inside, and so on? So I'm sure one last thing I just want to say that is that when you can use globals and locals, along with global, you can also use local to check what are your current global and local variables. So just run the global function and just say global and open and close bracket, see what you get, and locals, open and close bracket, see what you get. Another thing to keep in mind is that every time everything in Python is an object, and I can assign variables to function just like I can with numbers. So we'll go over this again when we talk about decorators, and do practice, and see you in the next session. In this section, we'll learn about errors and exception handling. We all make errors. You've seen during the course of my other videos, I have made a ton of syntax errors. I've made a lot of other end-of-line errors. So you can try this. Just try to do a print statement and miss the parenthesis and see what you get. You will get an error. And in this lecture, we'll primarily focus on how to handle those errors. I'm not talking about not making any mistakes, not making any errors at all. I'm not referencing to only the syntax errors, but there can be a whole lot of errors, especially when we are creating so many objects, when we are moving certain objects from a certain place to another place to do some sort of processing or compiling, or it could be many other things. We've seen very small examples, and the really large ones are also a part of assignments. We've seen some really great examples as we created class, and you've seen how we run into errors. And what do we do when we run into an error during our execution of the program itself? We can when we know that we can expect an error, and how do we still handle that error and continue to run our program? And now that's what we're going to focus on this particular lesson, and we'll understand how we do errors and exception handling. Let's begin with moving on to our Jupyter notebook, and let's get started. Now, for example, I do something like this, print, and I do so for example, I missed this and just say hello, and it says EOL while scanning string literal. Note, we have what we call is a syntax error with a further description that it was a EOL, which means end of line error, while scanning the string literal. So this is specific enough for us to see that we forgot to put a single quote at the end of the line. Now, understanding these various error types will not only help us debug our code much faster, but also helps us understand how we code, how our coding behavior is in general. So I'll take this out and I fix this with whatever was missing, and then we get the our right output. Now, this type of error and description is known as an exception. Even if a statement of expression is syntactically correct, it may cause an error when an attempt is made to execute it sometimes. Errors detected during execution are called exceptions and are not unconditionally fatal. So there are a list of built-in exceptions on the link here that I will share with you as we go through the class. Now let's learn how to handle errors and exceptions in our own code. Now let's begin with understanding how it works and what are the ways of handling. One of the ways is try and accept. Let's look at how this is a basic terminology and syntax used to handle errors in Python is try and accept statements. Now the code which can cause an exception to occur is put in the try block, and the handling of the exception is implemented in the accept block of the code. The syntax form is something like this. So it's a try, do your operations here, and then accept. We go to exception 1, then if there is exception 1, then execute this block. Then we have exception 2. If there is exception 2, should not be space, should not be space here. Then exception 2, then execute this block. Something like this, right? And after all that is done, this is also a statement, this is else. If there is no exception, then execute this block. This is a basic syntax of try and except. We can also do just check any of the exception with only using the except. Let's get a better understanding of all this with an example. Let's look at some code and let's see if we can open a particular file. So I'm not going to run this because this is not Python code, it's just a syntax. Let me mark it like this. Alright, now I'm going to try to open a file. Open a file. Remember from our, if you've not gone through the files data structure, please go through it now, and we've demonstrated how to open a file and write a file and read a file. So I'm going to say write, say test write this, okay, and then I created this f variable so I could use the methods on those objects like this, okay, and then we do except IO error. This is the name of my error, you can give it anything that you like, and then this will check for IO error exception and print. So something like that, print error, could not find file or read data. Because I don't have anything called test file, this will be giving an error, and when I get an error, I don't want my entire program to collapse and stop or freeze or do something else. So I need to handle those files. So I know I'm searching for a file. What if that file does not exist? That's when you put out an error. Say print content written successfully. What if I find that content? Yeah, so if I find the content, then find that particular file, then I would print, and after that, if I found the file, I would close it. This is how you write a program where you're dealing with anything to do with files, especially when you're trying to write and open and do some processing with it. This is what we do. So let's see what happens if I run this file. It says code written successfully, because it was able to find a test file, and because it's open, right? Open will create a new test file, and then it wrote to this, and then content was written successfully. Now let's see what happens if we don't have the write permission, it only read permission. Yeah. So let's see. I'm going to take this and I will change this to R. Now let's see what happens. What kind of an error? Because I only have read permission, and that means it should print an error that we want. It should say how to find that, and we got this error. Great. So notice how we only printed a statement, the code still ran, and we were able to continue doing actions and running code blocks. Now try to do this without the example of try and except, and you will see that your code does not actually run. So if I try to open a file and run and write something to it, and if I don't have permissions, the error that you get will stop your code from running. So this is extremely useful when you have to account for possible input errors in your code. You can be prepared for the error and keep running code instead of your code just breaking, as we saw above. We could have also just said except if we weren't sure that the exception would occur. For example, I will put something like this, and I know that we get this error could not. So what happens if I just paste this whole thing, yeah, and then I take this name error Alright, I'm going to just say except, and this will still do the same thing. So we don't actually have to memorize that list of exception types. And now, what if we kept wanting to run the code after the exception occurred? Right here, it ended. But what if we need the code to run continuously? Now that's where the finally comes in. That's another keyword. So going back to our syntax here, and if you thought else will stop, else is just a fallback condition. But what if I had something that I always wanted to run irrespective of the error, and that's where the finally comes in. So I would do something like this, except else. I'd also have a finally block instead of else, or I could also have else along with finally, and the code block would always be executed. And I'd say this code block will always be executed no matter what happens above. For let's see, for example, I'm going to take the same example. So let's copy all the way here. Yeah, and I'm going to change the rate permissions to write, and then oops, it did not want it to execute. So notice when I executed, it said end of line EOF while parsing end of file had a problem. So I didn't know what you wanted me to do with this. So there is some sort of a syntax error, something is not right, all that. So I would avoid that by doing something like this. Always execute finally code blocks no matter what happens in try. So it could not actually write this file, but like I showed you an error at the beginning, but it's finally, no matter what happens, it did not give me the same error it gave me earlier, but it actually printed this whatever when I said I had finally. So we can always use this in conjunction with except. Let's see a new example that will take into account a user putting in a wrong input. So I'm going to do something like this. So okay, let's say create a function, ask integer, and then try, okay, value is equal to integer. Raw input, I think in Python 3 it's only called input, and then say please enter an integer. If this is incorrect, we'll come back and change it. Okay, and then I would have except print looks like you did not enter an integer, and we'll finally print, and this should be in double quotes. Yep. Finally got fine. Okay. This line, this print shows up no matter what. Okay. And then I want to print whatever the user printed. Alright, let's see what happens when I run this. So I'm going to run this. Please enter an integer. I'm going to enter a string. So it says, looks like you did not enter an integer. This print shows up no matter what. And I also get some other errors, which is okay. So notice we got this error. First one is to importantly notice that it please enter an integer, it asked me, and it said looks like you did not enter an integer. So let's remedy this by asking the user and checking to make sure that the input type is an integer. And let's try and fix this code. Okay, I'm gonna copy this thing and let's fix this here. Okay, so I will add this part again. Yeah. Try again. Yep. And that should do. So that's all I need to do, and now see what happens. So I will do a ask int, and it will ask an integer and says oh, this shows up no matter what. So something isn't right about the way I have done this. And are you in a position to point out the error? Yeah. So let's see, because I entered an integer, that happened, and that's what happened. So what if I type a string and says, try again, please enter an integer, and I will write an integer, and this time it printed the value, and this also executed the finally. Yeah. So I did not get any other error. This time I did enter string, but I did not get any integer at all. So that's how it does. And how can I continuously put in a loop, if we may ask? What if there will be an error now. So first time I enter a string. What if I enter a string again the second time? So it'll still throwing up an error here. But what if I want to keep checking until my condition is met? That's simple. We are talking about, when I say until something is done, we're talking about a while loop. Yes, you got that right. So I'm going to do something like this: while true, try, and I will copy this, put this here, and so notice the indentation also in this. I need to have my except right under the tries, print. Looks like you did not enter an integer. And how I use all that I've learned in my previous session on loops, and then I put else, print, yep, that is an integer, and a break right there. And otherwise you do a finally print okay, just have that, and then in the end let's print out whatever the value entered by the user, just so we know. Alright, great. Now what happens if I do ask int please enter an integer? I will enter a string, and it says please enter an integer, and keeps asking me till I enter an integer. And what happens if I do a float? It says no, that's not an integer, so I have to enter an integer, and only then our code works. Yep, great. So now you know how to handle errors and exceptions in Python with the try, except, else, and finally notation. So this is all about error handling, and I'm glad that you were able to come this far. If you've not, please go over this once again and try out a few more examples on how to handle and write errors that you're expecting in your code. See you in the next class. Great. In this session, we're not going to do anything to do with code, but we will be understanding what are modules and packages. This is just a definition that I'd like to bring it to your attention, and then we'll see some examples later on in the course. You might see us importing a module. In the previous session, one of the videos, we imported a module called math. Modules in Python are simply files of Python which implement a set of functions, methods, and statements, and these modules are imported, or in some cases we import modules from other modules using the import command. Now, to import a module, we use the import command, but do click on the link that we have here in the resources section, where you can visit a list of all the available or existing modules that are out there. Now, the first time a module is loaded into a running Python script, and then it is initialized by executing the code in the module once. Now, if another module is in your code, imports the same module again, it will not be loaded twice, but loaded only once. So, local variables inside the module act as singleton, and they are initialized only once. Now, if we want to import a module math, like I was referring to, we just say import math. just like this in the picture. And then if I want to use it, I want to create a ceiling, or ceiling is a way of estimating. I can now run certain methods which are a part of that module by calling math.ceil, and I say 2.4. Now 2.4 will round it off to the highest next whole number, which is 3. So that's what that method does. Now let's explore some built-in modules. Two very important functions that come in handy when exploring modules in Python, which is the dir and help functions. Now we can look for functions that are implemented in each module by using the dir function that we have seen in the functions method. So when I do a docstring, it tells me what that particular function does, right? We can call upon the docstring and then we will know what that was. The same way, when you do print dir and put the library name, and it will give you something like this as an output. Now when we find the function in the module we want to use, we can read about it more using the Python help function inside the Python interpreter. So I put help and then say math.ceil, then it will tell me, okay, I'm trying to get you help on built-in function which is on ceiling. This will return the ceiling of x, and this is the smallest integral value that you can have. So that's how the help function works. So help helps us describe or know what a particular module does. Now we can also write our own modules, which is very simple. So to create a simple module of our own, we create a .py file, which is a Python file. Just type your code and then import it using the Python file name. So for example, you can write a file that prints hello world, right, and then name it hello world. In another file which prints, you can import that hello world and then be able to run the print just like you run it from any other method. So that is how you write your own modules. Let's also talk about packages. Packages are collection of such methods or libraries, and which are also called namespaces that contain multiple packages. They get very complex. An example of a package can be NumPy or SciPy. So these are these contain multiple packages and modules themselves. They are simply directories, but with a twist to the way they function. So each of these packages in Python is a directory, which must contain a special file, like a special method, which is the _init .py. Now this file can be empty, and it indicates that the directory it contains is a Python package, and you have to initialize this, so it can be imported the same way that you import a method, right, or import a module. So if we create a directory called foo, which marks the package name, when we can create a module inside the package called bar. So we also must not forget to add the _init.py file inside the foo directory, something like this. So just as an example, I can then import foo.bar like this, but it won't work. But I could do from foo import bar. So like we did in the math function, right? From math we can import only the ceiling function. In the first method, we must use the foo prefix whenever we access the module bar, like we have to do math.ceil. In the second method, we don't, because we import the module directly. So I can directly call the method called ceiling or ceil or bar, because I have already imported that out of that particular package. So we can also decide which module the package exports as the API while keeping all other. So for example, I do a init.py, and then I can actually export all the methods by using the _all method, special method, and I can mention the name of that method. So that's it to do with modules and packages, and see you in the next class where we learn about regular expressions. Thank you for watching. Great. Regular expressions are text matching patterns described with a formal syntax. In this lecture, we'll focus on regular expressions. Think of something like you are doing a search and you want to use certain keywords and also certain parameters to be able to arrive at your particular search result explicitly. So sometimes you may have searched in Google using double quotes, and so that your keyword gets prominence and searches only in their index only based on that particular keyword. So you'll often hear Regular expression in Python is something that's similar to search, but you'll hear them as regex or also heard as regexp in conversations. So regular expressions can import or include a variety of rules, from finding repetition to text matching something during a search, and so much more it could do. Now, as you advance in Python, you'll see that a lot of your parsing problems can be solved with regular expressions. They're also a very common interview question. So, well, if you are familiar with any other language, let's say like Perl, then you'll notice that the syntax for regular expression are similar in Python, and we'll be using the similar re module with Python. Let's get started. So I'm going to shift over to my Jupyter notebook, and then let's get started in working on regular expressions. Great. Now, in regular expression, one of the most common use cases that we come across regular expression is for finding patterns in text. Like I was giving you an example of search, right? What exactly happens if you Google search for something which says, so let's open Google real quick, and I'm not saying this is exactly how Google works. I'm just quoting this as an example. So if I say, so FIFA is going on as I'm typing this code, so I want to say goals FIFA right. So I want to just type this FIFA goals, and I want to only talk about the goals, and the search results will only get me for the keyword FIFA 2018. FIFA 2018 is a part of all my search results. So that's what happens when I use regular expressions. So regular expressions help a program match. Google uses a much more complicated setup, indexing and many other things perhaps, but here we are only talking about a quick way of finding patterns in text. Let's do a quick example and use of search method in this to using a re module. So we import a module called re. RE stands for regular expressions, and then I want to put a list of patterns which I want to search. For example, like we gave the goals, right, for, I'm going to say term 1, and then there is a term 2. So there are two terms, one is FIFA 2018 and then term 2 is goals, for example. I'm just referring to that, and then I'm going to give it some text that I want to parse. Text I want to parse, patterns I want to search, yeah, and this is my search keyword, and then this is the pattern I want to search in, yep, and then I say text. Now I'm going to put a string. This is a string with term 1, yeah, and then but it also has term 2. Let's say something like this, and term 1 is repeated. Let's see, let's just make it a little complicated. Now use a for loop to iterate over this particular object like this. So for iterate over this pattern, so something like this, for all the pattern in patterns, print searching for. Okay, so let's make it more interesting. I'm going to say all right. Okay, so let's just say we only have term 1 that it's looking for, and then we'll come back and make it something much better. Searching for, I'll do something like this. Yeah, this is called a string, and then in backslash, yeah, so okay, inside this, and then I have this, and this something like this, and say pattern, comma, say text, right? So we take the text, and I'm not sure what will happen. Let's see how it works. Check for a match is done. So now that I have iterated, so I'll say if you find search, this is a method of coming from the library of regular expressions, and then I will say search for pattern in the text that we have, then print whatever you find, yeah, oops, then print if the match was found, and go to the next line. Else print print no match was found. So now it says searching for term 1. So if you notice how this works, now we've seen that the research will take into account whatever we have asked it to search, and then it will scan the object, and if there is no pattern found, it will return a none, yeah, and if, because it said a no match was found. But if to give a clear out, let's check out this example below. Okay, I'm going to take this same thing, yeah, I'm going to say list of that things that we want to search for, and I'll only put term 1 in this, and then I'll have the same thing in this case, which is our text to parse. I'll copy paste this, then I'd say match is equal to, yeah, and print the type of match. So this prints out match object returned by the search method is more than what just it contains the information about the match, including the original input, the string that was used, and the location of the match. So now I can do methods like this, yeah, I can say it has 22 characters, there are certain methods, then I can say where is my match word, and from what word to what word, and from the 22nd index to 27th index is where I have. So that is a beginning of regular expressions. I just wanted to give you a demo. It doesn't matter if you're not able to understand the whole thing, but we will see regular expressions much in deeper in the later parts of the course in phase 2 of Python, but this is just to get you started in understanding regular expressions. So we look at more examples in the next class. Thank you so much for watching, and I hope you get to practice all that we have in regular expressions, and you got a foundation of what regular expressions are. Thank you for watching, and see you in the next class. Welcome back, and this is another section where we'll learn about iterators and generators, and we'll learn the difference between iteration and generation in Python, and how we can construct our own generators with the yield statement. Generators allow us to generate as we go along instead of holding everything in memory. So that's why generators are much more efficient. Now we've touched on this topic in the past when we were actually talking about the range function, and with difference between the X range was being a generator while range was not, right? So let's explore a little deep. We've learned how to create functions with the def and the return statement. Generators allow us to write a function that can send back a value, then later resume to pick it up where it led off. So the type of function is a generator in Python, allowing us to generate a sequence of values over time. The main difference in syntax will be use of the yield statement. So we'll see that in an example, but before we get to that example, I just want to explain that in most aspects, a generator function will appear very similar to any other function, but the main difference will be that when a generator is compiled, they become an object that support an iteration protocol. That means when they are called in your code, you don't actually have to return a value and then exit, but the generator functions will automatically suspend and resume their execution and state around the last piece of value or last point of value generation. This is the reason, this is a basic functionality of what a generator does. But the main advantage here is that instead of having to compute an entire series of values up front and keep it in memory, generator functions can be suspended. Now this feature is also called as state suspension. I'll share some reading materials after this, but to get start a better understanding of generators, let's go ahead and see how we can create some. And I'm going to open my notebook here, and let's get started with some examples. So to start getting a better understanding of generators, let's go ahead and see how we can create some. And this is how we create a function, right? So, and I'm going to create a function, and then it says n. So this is a generator function for the cube of numbers, so the power of 3. This is how we do it for all numbers in range. I'm using the range function, right, and which is a built-in function, and it yield a number 3. This is a not similar to a return statement, but it does not keep anything in memory, while a return statement keeps in the memory. This runs through the iteration, but return is a statement that returns a value after the iteration process is done. So I'll show you this is in the example. And if I do an execution of this particular function, and then I print the value of x, and it prints me the cubes of all the numbers from 0 to 10. So now we have a generator. We don't have to keep track of every single cube we created, right? Generators are best for calculating large set of results, particularly in calculations that involve loops themselves. So it's very important that we use generators and know where to use generators. Generators are used in cases where we don't want to allocate the memory for all the results or at the same time. So in this case, I'm not sequentially tracking them, I'm not allocating any memory, and that's when I use generators. It improves the efficiency of your program. The yield statement does not keep anything in memory, unlike the return statement. And let's create another example of a generator which creates Fibonacci series. If you don't know what is Fibonacci series, you'll get a primer on this soon. But if you'd like to read about it, feel free to read it. Fibonacci series is nothing but it adds the previous number and prints the result. So let's see what I'm talking about. I'm going to create a decorator function, which is a generator function, and that will. So I'll use the doc string, and this is how we create a generator according to standards. Yep, and that's how we do it, and that will help users know what this function is all about. And I will assign these values. So I will begin my Fibonacci series from 1. Now for all items in my range, yield A, which is A and B, take A and B, assign the values, and then do print A plus B. So that's what a Fibonacci series is all about, right? So if I print this like this for every number in, right, then print the number. Now when I do this, when I do this, it will print the Fibonacci series. So 1 plus 1 is, it starts with 1, takes 1 and prints 1. All right, so that's how we have A and B are printed like this. A and B are printed, and now it takes B. It takes this B and then adds that B with a value of A, which is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8, and so on all the way till the range 10, right? So what if this was a normal function? How would it look like? So if I had to do a normal function, I would do something like this, give it a name, and then it would take a number as value, and then A is equal to 1, B is equal to 1, and I need to define how I want my output. So I want an output as an array, right? And I would iterate over it like this in the same way I did for a generator. Only thing is I will do an append method which will append my output list with values it generates during the iteration, and we know lists are appendable, and then I would do A plus B, and then let's return output. So what do you think this should have? This should give you a list of Fibonacci numbers. When I run this function. So let's say, and it will return a list. Notice how we can call some huge values. So if I change this value to 100, 1000, the second function will have to keep track of every single result, right? And in our case, so this we actually only care about the previous result to generate the next one, right? In this case, it has to keep a track of this, and then it should be able to iterate over every number in the range and go back and then maintain a list. Right. So next, look at some built-in functions in the next session. I hope you are clear. So see you in the next class. So in this session, we'll learn about next and iter built-in functions, which is a key to fully understand generators. Because you might be wondering, it's pretty much the same, how are things different? Generator is also a function, I could do a function. Okay, yield and return are something different, but I'm still not very clear about generators. So that's where fully understanding generators, we'll use next and iter, which are built-in functions. So the next function allows us to access the next element in a sequence, and iter does something similar. Let's check it out. And I'm going to go over to my Jupyter notebook, and I will be talking about iter and next functions, right? Great. Let's see an example. So I'm going to say create a function, or sorry, create a generator, and it will be a simple generator. Okay. Then for all x in range, yield x. Yeah. So now I'm going to assign a simple gensum value, g is equal to. So I've assigned my function a value. Now if I print next of g, it starts with 0 like this, and then I'm just preparing it to print every number again, and second time I print, it will print 1. The third time I print, the fourth time I print, it says stop iteration. So because it's only printing till 3, which is 0, 1 and 2, and it stops iteration after that. After yielding all the values, next caused the stop iteration error. What this error informs us is that the values have been yielded. You might be wondering that why don't we get this error while using a for loop? The for loop automatically catches this error and stops calling next. Let's go ahead and check out how to use the iter method. So we know that strings are iterables, right? So I'm going to create a string and say hello, and on the same way I will iterate over the thing. So for all in letters in S, print letter, right? So this will print all the letters like this. We know we've done this in the previous class, but that doesn't mean the string itself is an iterator, right? We can check this with the next function. So I'm going to say next, and now I iterate over each object. Interesting, we just got an error. This means that a string object supports iteration, but we cannot directly iterate over it as we could with a generator function. Now that is where iter function allows us to do just that. So now I'm going to say is equal to create an object called s_iter, which is nothing but has a method for iterating over our object. Then I will take next, and then I will iterate over this, and I have built in the capabilities for my next method, the capabilities of iteration, and now I can iterate over my string each time like this. So I keep going again and again, and it until all the letters are done. Yeah, and see what happens, and it stops iteration. Great. So now you know how to convert objects that are iterable to iterators themselves. The main takeaway from this lecture is that using the yield keyword at a function, we will cause the function to become a generator. So it's nothing, everything is the same, but I only put a keyword called yield, and that makes this function a generator. Now this change can save us a lot of memory for large use cases. There are some informative links that you can check it out and understanding more about generators. Thanks for watching. Hi and welcome back. In this session we'll be learning about object-oriented programming. Now what is object-oriented programming? You've heard about this many times, or probably not. Probably this is the first time you're coming across a statement called object-oriented programming. Let me put it this way. Before I even define or begin to talk about object-oriented programming, let me set the stage that it is one of the most complex parts for beginners. If you're coming from no other language, and if your Python is the first language and you're starting from scratch, then object-oriented programming is the hardest part because it's not exactly hard, it's just the place where everybody gets confused. So let's start to begin to see how simple it is, and in this session we're going to simplify what object-oriented programming is and what exactly it means in the world of programming. And Python being an object-oriented programming language, it is very simple. And isn't simplicity a part of Python's design as well? So design philosophy. So let's get started with understanding what Python's object-oriented programming is. But you can also feel free to Google search a lot of articles out there on Python that tell you about how things work. And maybe there are a lot of other examples, but in this one we'll cover something more relevant which we believe will make you understand or lay a great foundation. And it is really important if you can get this object-oriented programming straight and understand this and spend a lot of time and many examples and hands-on, also go over the assignments. I'm sure that you will have no problem understanding not just Python but any other language in future. So let's begin to understand what Python is. Let's construct something wherein then we will be able to understand what is an object, what is a class. So in Python, we know everything is called an object. Now let's see how we can create those objects using the class keyword, and then how we can create the class attributes, and we'll learn about creating methods in a class. Then we'll learn about inheritance and learn about some special methods for classes. So let's begin with understanding what Python is going to be, what a Python object is going to be. Let's begin with something very simple, something that's more flexible. Let's start with what we call a list. And I'll switch over to my PC here, and let's begin with the first example. All right, so I'm on my screen right now, and on my Jupyter notebook is running. And in this, I will create a simple object called list and give it a variable called L, and let's say it's a list of integers. Now, do you remember how we used to call methods on a list? For example, I'm referring to a method. So I want to see how many times the letter 2 is called out. This is very simple, right? It's 1. So what we're basically doing in this lecture is we're exploring how we could create an object type like a list. So we've already learned about how to create a function. So let's explore objects in general. Now, in Python, once again, I know I've repeated this many times, but let me also repeat this now and get your attention, and also demonstrate this as an example by saying in Python everything is an object. Now remember that we could use something like type, and this tells us how to check the type of an object. So Python is a very intuitive language, and it already understands you don't have to declare a variable type explicitly. Python understands the type of your variable by default. So for example, if I say print type of this, so Python already knows this is an integer. Let's see, let's bring out all the type of all our types that we have, and then see what happens. Okay, so that is, we know is a list. And let's see if Python recognizes a tuple. Yeah, so that's a tuple. And then I'm going to see if Python recognizes a type of what we call curly braces. You know what curly braces are. If you don't, then wait for the output. So we've covered, and let's also see what this would be if I put something like this. Yeah, type of, and I'm going to say something. So this will print out, oops, okay, I have missed a parenthesis. Great. So now this is a integer class. This type is integer. This is a list, right? This is a tuple. This is a dictionary, and this is a string. So Python by default understands based on your type, based on what you put inside. So, and we know that from this we can arrive at a conclusion that these things are objects. Now, how can we create our own object types? Now, these are inbuilt, correct? So Python can easily recognize it without us declaring it. But how do we define our own object types? And that is where the class keyword comes in. Now, sometimes we'll have to define our own type of objects. So that becomes the definition of class. So the class is a user-defined object that are created by using the class keyword. Now, class is also a blueprint that defines a nature of a future object. Now, from classes, we can construct what we call instances. An instance is a specific object created from a particular class. For example, in the list that we have here, we created an object L, right? We created this L, which was an instance of a list object, correct? This is an instance of a list object. The same way, let's see how we can use class. Okay, now we're going to create a new object called sample, or let's call it an example. Okay, so I'm commenting this saying create a new object type called example. I'm going to create this class, class, and then I will say example. Yeah, and I know you might be wondering why I used capital letter when I was talking about small letters for PEP 8. For classes alone in Python, we use the capital letter when we're declaring a new class. And then let's put a pause. So this class for now does not do anything. Now I'm going to create a instance of example. So like you just created an instance of a list here, I'm going to create an instance of sample example and say something like this, right? And just like this we did. And now I'm going to say print type of x and then put them both in parentheses. Yeah. So now this should, what do you think this should return? What do you think this should be there? And let's see how this behaves. It says class main example. So by convention, we give capital letters for classes, and x is the reference. We're referencing x to our new instance of an example class. In other words, we have instantiated the example class. Now inside of the class, we currently just have nothing but just a pass, but we can define class attributes or methods. Oh, what did I just say? I just said two new keywords. I mentioned attributes and methods. What are they? An attribute is a characteristic of an object, and a method is the operation we can perform with the object. So this is really crucial. I know it doesn't make sense without an example, but let's see. Let's try out an example. Let's say we can create a class called dog. An attribute of a dog, maybe its breed, or let's say it could be its name. A method of a dog may be defined by what a dog can do. What can a dog do? Let's say a typical dog would bark. So bark is a method which returns a sound, for example. So let's get a better understanding of these attributes with this example. So, but before we get there, I just want to talk about the attribute. The syntax of creating an attribute is like this. Attribute, and then we have something. Okay, so this is how we create. This is a syntax of an attribute, and then there is a special method. It's called init, and now this one initializes or instantiates attributes for an object. So let's start with an example. Let's see if we can create a dog. I'm going to create more cells here. All right. Okay, so I'm going to create a class, for example, and then I'm going to give it a name called dog, and let's say it takes in an object. So I would then type this instantiate. I'll explain this in a while. So it's also called Dundee, which is nothing but underscore, and then it takes in two parameters, itself and the breed. Now breed is the attribute, so this is how we set up an attribute. Then now you can see how it becomes. So it becomes so easy. So I can say oops, let's say this is what it is, and then the breed is equal to a Labrador. And then we have what are good dog names? Let's just say Tommy, and I'm going to call it a breed called Husky. Right. So let's break down what we've done, and what's that special method. Here we have, it's a special method. So this is, so we just created a dog class, and then the init special method is called automatically right after the object has been created. Now each attribute in a class definition begins with a reference to that instance object, right? So it is by convention, it is named as self. The value passed during the class instantiation, it becomes the type of the attribute. Now we have created two instances of the dog class that we have here with two breed types. One is a lab and another is a husky. And now that we have created this, we can access them something using attributes like this. So for example, I can just say Scooby.breed, and then it should print out whatever the breed is. Right? Simple, isn't it? And at the same time, I can say Tommy.breed, and note how we don't have any parenthesis after the breed. Now this is because it's an attribute and it does not contain any arguments. In Python there is also class object attributes. Now these class object attributes are the same for any instance for the class. For example, we could create the attribute species for the dog class. Now dogs, regardless of their breed, name or other attributes, will always be mammals. So we apply this logic in this way. So I will edit this, and I'm going to actually take this very same thing, right, and I'll put this here, but I'm going to add another class object attribute. This is a class object attribute instance and not a instance of a class like what we have here. So there's a difference. You'll see this. Now this is a mammal, right? And I can also have self. I can also modify to take a name, right? And in that name, I can do name like this, dot name, which is equal to a name, right? So now what happens? Now this becomes like this. So we need to create an instance like this, and it will be a lab, and it will be a name, right? So that's how it becomes. Now I could do something like this, and I could do note that the class object attribute is defined outside. This is our class object method, right, where we have a special method and we are assigning the attributes to the dog object, right, to whatever the instance we're going to create in the future. We are assigning it a like, for example, a method. So a method will be doing nothing but giving us the list of whatever the value it carries. Like in this case, it carries this lab and name of the dog. But this is where we talk about what we are doing a class object attribute. So let's see some more examples in the next session. So for now, I hope you got to understand the special method and how we declare a object. See you in the next class. Now resuming object-oriented part 2, starting object-oriented part 2 on this screen recording. All right, so methods, we just saw in the previous session how the class object attribute is defined outside. This is the class object attribute and how this is defined outside of the method in the class. Also, by convention, we place them before the init method is called for the first time in that particular class. So what happens is with this, now I can do something like call upon the species, right, and then this should return whatever the species is. In our case, it's mammal. So that's about a class attribute, but look at the methods. Let's focus on the methods. Now this is a method that we have created, and methods are, in some ways we have used the def keyword, right. So methods are functions defined inside the body of a class. Now why are they still called methods? Because they don't exactly fit in the definition of a function, because a function is something that is created to avoid some sort of repetition, so you can keep calling it at multiple places in your program. But methods are something that are used to perform operations with the attributes of our object. So it's restricted by that particular object within that particular class. So methods are essential, however, in what we call encapsulation concept chapter of object-oriented programming paradigm. Now this is essential in dividing responsibilities in programming, especially in large applications. Now you can basically think of methods as functions acting on an object that take the object itself into account through what we call the self argument, right. So in this case, the self takes the object itself into the account. So that is what is letting us call upon this method here, because we are referencing the dog object by calling the instance Scooby, and then being able to take reference of breed, because breed is by associated with dog by the self keyword, right. Sorry, self argument. So let's go through another example. Let's create a circle class. All right, so I'm going to go back over here. Let's create more cells. Oops, not there, but we create more cells here. And all right, so I'm going to create my class and I will name it circle. Inside that, I will type object. Then, so before I instantiate the class with any object attribute, let me define the value of pi, which is 3.14. Now I need to create a circle, that circle, oops, that's not circle, to instantiate with a circle has a radius. So let's start with that, and this is how we do it, and down D in it, and that's it. So inside that, I'll have to have self by convention, and then I will have radius, and the radius, let's say, will have a default value of 1, and after that I will reference it like this. So by doing this, I'm allowing this method to allocate this particular object and associate it with the class called circle. This attribute, this object attribute, is now a part of this major class, right. And I hope you're getting this. Now let's say we will write a function to calculate the area of the circle. Let's just say area of the circle, and that's how we do it. So now this is a method, and this method is restricted only for this particular class, right, and it will return self.radius and multiplied by self.radius pi multiplied by pi. So I could have done something like this. I mean, I could have taken this off, and I could have said actual area is equal to pi r square, and then I could have said print actual area and so on. I'm just trying to reduce the number of lines, so let's put this like this, and this will straight away return us this value of the radius. Now after I did this, I need to, and the radius need to be reset to 1. How do we do that? So I can call another method to do something like that. So the set radius, this is how we do it. Right, so I can create a method on top of an attribute that is already instantiated. Okay, so I do self dot radius is equal to radius. So note that this radius is the same radius as this, right? So I can be sure that the radius value is reset back to this, and after that I can do a method to get radius, like something like this, and always the self keyword is the first one that I write. Unless there are additional attributes that go in, I don't do mention that. So in a previous example, we had an additional attribute called name for object. There is only one self. So anything I put after this, it could be breed, name, habits, it could be anything else, and all of this will become a part of this particular object. So going back to our example, I'm going to get radius, and that will return the radius, right? So, and after this I'm referencing the object class to our variable object here, right? So that I can use this in our other, so I can print, for example, print or let's do C set radius is, let's say, 2, and I'm passing the value of 2 for set radius. And then once that is done, so I can use this C to set these methods, or run these methods, in this case set radius, and then radius is get radius, right? And so notice how I'm running these methods. Okay, so let's see what this does. I'm just going to get rid of extra spaces here, so it looks neat and tidy. Great. So there is a name error we've got, and it says pi is not defined. Let's try and see if we could troubleshoot this. So it says pi is not defined. Let's see what happens if I do like something like this. Okay, great. So I cannot use pi because pi is declared outside of the method, but I can definitely put the value straight away. We'll come back and resolve this, but for now it says radius is 2. When the radius is 2, the area is 12.56. Right. So notice how we use the self notation to reference attributes of the class within the method calls. So be it Flask, you may learn later on, or Django, or run any sort of data science methods or libraries of Python, the self attribute is very important, and we use this to notation to reference attributes of the class within the method calls. So just do go over once again on how the above code works and try to create your own method. As an exercise, see if you can come up with a square where you calculate the area of a square, and you can always reference the formulas in Google, and I think calculating the square is pretty straightforward. And try to come up with methods of your own for a square, for a rectangle, and for a pentagon. And if you're able to do that, let's move on to learn about inheritance in the next class. Great. Now we have come to an understanding of what is a method and what is a class, and how the self notation is used to reference the attributes of an object within a class, right? And then we were able to reference that particular class object and then call upon those methods by using the variable of a reference that we have used in the previous example. In this session, let's learn about what is inheritance. Now, inheritance is a way to form new classes using the classes that have already been defined. That's very important. So, inheritance happens where you are inheriting certain properties of a parent class, and in some ways we are creating a class object within an existing class object where some of the attributes or properties of that particular object or class are inherited by its parent. So, the newly formed classes will be called as derived classes, and the classes that we derived from are called base classes, or in some languages it is also called a parent class and a child class. It is something similar to that. And important benefits of inheritance are helping to reuse existing code or try to reduce the complexity of a particular program. Now, the derived classes, also called as children or descendants, override or extend the functionality of base classes, or parents are also called ancestors. Now, let us see an example on incorporating our previous work on the dog class that we created, and I will show an example on my screen here. Great. Let us come up with an example of how inheritance works on my screen. I have Jupyter Notebook back on the same notebook that we've been working on, and I'm going to create a class called animal, and it takes an object, right? And when I say object, we can start defining them. The first one, let's start with defining the method, special method itself. We're not going to create any class attribute like we created earlier, and then I'll say print animal created, so we know what time what gets created. All right, and after that I'm going to create another method which will just say who am I. It takes in self. I'm referencing the self. When I create a who am I, this method belongs to the animal class, and how do I bring that relation is by typing the word self. The moment I type self, Python allocates this particular method to the animal class that we have created, and then I say print animal. Great, and then I'm going to create a method and assign it to the dog class, and it's say eating, right? Now let's create another class. Yeah, so I'll say class dog. Now this time what I will do is I will call the above class. So this particular class will inherit all the methods inside of animal. I'll show it in the example, and let's see, every time we create a class we instantiate it, okay, and then I can also instantiate the animal class like this. Yep, and then we say dog class created, or just say dog created. Now I'll create some more functions like this. I'll create the same method. There's one method inside of animal. I'm creating the same method with the same name, but inside of the dog, just to demonstrate how it works. So here the who am I will be a dog, but here who am I will print animal. Let's see how that works if I have the same methods, and how does it work. And then I have something like this, okay, just to make it interesting. Now what should happen here, if I need to create a reference, right? So I'll do something like this. Okay, so the moment I do this, it should instantiate this, and while instantiating it, it also has a task of this dog will instantiate not only dog class but also animal class here, and then it should print something. And if you notice, while if we are creating the animal class, then it also has to instantiate this and then also print this. So let's see which one gets created first, right? So great. So when I said animal created, it actually first, when we ran dog said, hey, I have a reference class of animal, and is there an animal class existing? It says yes, animal class does exist. Is there a instantiate method written by the programmer? And then it returns yes, there is one. So okay, let's instantiate that method. Is there anything else there is in apart from instantiating in the method? Oh yes, there is a print statement. Let me go ahead and print that first. All right, I've print the statement. Now I need to create the dog. Right. So is there a method that will instantiate that particular class? Then is yes, there is one. All right, I've instantiated it. Is there anything else that I need to do? Of course, there is a print statement, and that should say dog created. Great, I did that, and I'm done. So that's what exactly happened, and then we have the two classes created. Now what happens? Now I can call upon those methods, right? So this was our method, and then let's see what happens if I do this. It says bound method dog dot who am I of main dog object. So this is some sort of an error that we're getting because I haven't put this, and now we got the dog, right? Right. So I do this. Oops, it's eat, and then it get eating, and I can also do. So all my dog methods are working. Now in this example, we have like you've seen, we have two classes, animal and the dog. Now let's go over the basic definition before we, I know you have a lot of questions, but before we get there and I answer some of them which I expect are likely to be in your mind, let's say we have two classes, animal and dog, right? This is animal and this is dog. Now the animal is the base class, okay? So this is base class, and this is derived class. Oops. Right. So the derived class inherits the functionality of the base class. Now if you notice, I did a eat method, right? Do I have a eat method inside the dog? No. Eat method comes from the animal, and it says, it prints the method that we have, and the derived class modifies the existing behavior of the base class. That's what we saw in the example, who am I, right? And finally, the derived class extends the functionality of the base class by defining a new Bark method that we have here. Right. Now finally, let's go over the special methods in the next class, but for now I hope you understood how inheritance works, what's a base class, and how it overrides what's a derived class, and how the derived class overrides in this case, who am I, override certain methods of the parent class. All right, great. So let's see in the next class where we'll discuss about special methods. Great. So now let's look at some special methods. Classes in Python can implement certain operations with special method names. These methods are not actually called directly but by Python specific language syntax. Now let's look at another example here. Okay. So in this example, I'm going to create a new class and then create some special methods. So the first is to create a class, and this is our class, and then we instantiate it or initialize it with the self keyword. Now the book, I will set it to take in some arguments like title, author, page, right, and or let's say pages. And alright, so after that, like the way we've created this, and there is a semicolon, and then we say print a book is created, and I will say some methods. Pages, and it takes in pages. Great. So now I want to talk about a string method, a special method. Okay, and now I will do a string method, and it will be a special method. Return title, something like this, and this will then get me author, and the percentage will actually get us that particular value, and then get pages, and we'll get that. Now notice what we do, I also use another percentage sign, and then I would actually put out a self title I'm sorry, there should be self dot title, self dot author, self dot pages. Yeah, and then I can also do the other methods that we know about, which is length. Now it will say return self dot pages, then delete method. Okay, now I'm going to say book is referencing it by the class, and say Python is awesome, book written by KnowledgeHut, and it has 359 pages, right? Now I can call upon the special, see, when I say print book, print length of the book, yeah, and then I can say delete book. Let's see what happens. Invalid syntax, and I need to be something like this. Great. So a book is created, and the book is created, has this title, has this author, and has so many pages, and after that it says a book is destroyed, right? It actually prints the length of that book, which is 350. It's taking it from this, right, and I'm allocating it here by calling upon self and calling upon pages. These are special methods, are defined by their use of underscores. Now they allow us to use Python specific functions on objects created on our class. Great. After this lecture, you should have a basic understanding of how object-oriented programming works, how classes are created, how the self argument is used to assign a particular object to the class that we have created, and then how do special methods work. And we will be utilizing this heavily in our next milestone in the project. I have a few resources lined up for you, a few links that I think should be going through, and in order to establish a much more deeper understanding of object-oriented programming. Thanks for watching. See you in the next class. Great, I hope that was fun, and that was a lot of learning. So we've just went through phase 1, and I think it's time for you to celebrate. You've lasted all this while, and you've went through all the videos, and I'm glad that you were able to also practice. If you have not, please do practice this. It's very important. Practice is key to the success of you becoming a great Python developer and continue the journey on whatever you want to become and learning Python. So we learned about all the basics data structures. Be sure to practice them. And there are certain websites that I'm referencing on this video where you can go and test your mettle on Python by solving some challenges and see where you stand them against other people out there. So those are going to be very tricky. They're going to test your skills, but I believe very strongly that you will be able to solve them. Again, you have to commit time. The more time you commit, the better you become as a Python developer. You cannot become an expert at something by only going over these videos. They're only introductions, but I'm sure you're one of those people who will actually give this time and attention it requires, and practice and become marinate in Python and become a seasoned Python developer. And I will see you in phase 2, where I'm super excited that now that we have knocked off phase 1 and all the basics with covered and a strong foundation in our kitty, I think we will be able to go on, stamp on some of those cool Python libraries and phase 2, and we're going to do so much more with all that we've learned so far. So see you in phase 2, guys, and I hope all this was fun, and I'm glad to see you learning and becoming a Python developers on your own. Thank you, and see you in the next phase. Bye-bye. Thank you so much for watching this video and all the series phase 1, and I'll be glad to see you in phase 2 and walk you through some more Python in phase 2. Thank you so much. Great, so we've learned a lot of Python so far. We're pretty much done with all the data structures that there is to learn. Be it we've learned all the basics that is there, and that would have laid a solid foundation. And in this session, we will talk about files, a really interesting concept. We'll start with basics, and we'll build on to work with a lot of files later. So we know that everything in Python is an object, and if I haven't mentioned that earlier, please note that everything in Python is considered as an object. Now, file is also an object. In Python, uses these files objects to interact with external files on your computer. Now, be it any audio file, text file, emails, presentations, you can use these file objects to be any sort of a file you have on your computer. And you will need to install certain libraries, of course, or modules to interact with those various file types. And they're very much easily available. There's a list of modules that you can use, and they're pretty useful and handy, easy to implement as well. We'll cover downloading modules later on in the course, but let's exploit what already is built in Python. And there is Python can easily work on open formats like txt, and it has a built-in open function that allows us to open and play with basic file types. So first, we need a file though. So we're going to use use IPython or Jupyter to write a file, and then let's see how it all turns out and developer understanding of how to handle files in Python. Great. I'm moving on to my screen. All right.
Let me maximize this. I'm going to open a file. Let's say that's the first step, right? So how do we do that? It is pretty simple. I'm going to, let's say, suggesting this with, let's say I'm going to add write file, and this is a simple function that allows us to write a file, say test.txt, and this will get me to create a file called test.txt, and then say I'm going to put some words. This is some text for my file, and let's see what happens if I run this. It says writing test. So this is how now a file is written. If I go to my Finder and then I go wherever my file is located, I have a long way to navigate, but it will not take a lot of time. Yeah, there is my workspace, and then I have Python training, and I have another folder here. Great. So this is in a place you can notice that I have test.txt stored. It's in the same place where I have my files running. Let's go back and I would like to show you that this file is created. Now we can go and read this file, but to read any file, we need to click on it, open it, right? So we have to do something similar in Python. We have to open a file first, and there is a function to do that. It's called open function. And the open function also takes in some arguments, or also called parameters. And let's see how they are used. So I'm going to say my file. I'm also assigning it a variable name, and then I will use the function open. I could have just written open and then given the file name like this, test.txt. This also would have opened it, but what do I do with it next? So to handle that, I have created a variable and I've assigned it a value so that I can run this function and retain that in memory, that or keep the file open in memory of Python. And then once we open the file, the next obvious method is to read, correct? So there is a read function. It's very obvious, and I'll use, now I don't need to assign, I just need to call that method, and that's how we read a file. So it's printing out everything we have on the file. So this is how it works, and what happens if I run this again? I want to read this again. Notice that you got just two semicolons here, single quotes, because it happens because you can imagine that you're reading a book and there's a reading cursor, and that goes to the end of the line of the file after having read it. So there is nothing left to read, and it's come to the end, and we need to reset that cursor back. So that's something we need to do, and it's done by the seek method. So I can run that seek method on this by telling seek and go back to my first index, which is 0. And now I read again, run this, and this reads this again. So that's how it works. So we can write to a file as well. So you might ask me, how do I write to a file again? Once I've written first time, and I want to write something on top of that, because the open function will only allow you to read the file. Once you have it open, you have to read. What about write? Great. So the great question. To be able to write, we need to sort of first give it permission to write. So I'll take my file and I will open it. Okay, and I will say which file I want you to open. Then I say give permission, make it writable. So when I do this, I will be able to write files into this. So this is very fairly simple. And then after this is done, I will use a write function. And in this, I will say this is a new line of text. All right, great. So now I will try to run this read again. It's still not there because we've already run this, and my cursor is at the end of it. So let's see what happens if I try to read this. So there is this new line of text that has come in. So that's how it works. So what is this is happening? What happened to whatever I typed first? So for that we have to do the write file again, to overwrite something. So let's try to overwrite that again. So we'll take this first thing that I had earlier. Let's make a quick preview of this, and also let's see if we can use a for loop, so I can iterate over a text file. And so I'm going to call it the same. In this, I'm going to say first line, second line. Okay, so this will overwrite. Overwriting test will happen after this. Now we can use a little bit of flow. We'll look at flow in a later part of the time. But flow is a sense of also called for loop. Is also part of the flow. We'll look at it as we go. And this flow tells the program to go every line and do something. Let's say for every line in my file, which is open, I'll use it under open, and I want you to, hey Python, I want you to print whatever is in the line. So I want you to print each line. And okay, it says missing parentheses, and it says so it's printing the first line and the second line that way. So don't worry about fully understanding this yet. For loops are coming up soon, but we'll break it down and what we did above. Now, we said that every line in this text file, and we said, go ahead and print that line. We could have called the line object anything. So I can take this same thing, and I'll say, I can call this James Bond, and this is also James Bond, and I print this, it's still printing this. The way Python sees it, it understands that you're addressing the objects or elements inside your file name, and that's not of any relevance to Python. What is most of relevance is that the for loop, in, open function, and print. These are really important. By not calling read on the file, like earlier that we did here, we're actually reading the file by using the for loop. And this way, the text file is not stored in memory. So know that memory storage is sometimes really costly. So that is one way of reducing your time of execution of your program and helping you execute faster using flow control. And there's also notice that there is an indent on the line for this, and there is also a parenthesis for the print. And this white space is required. There is this indent in the second line, right after the colon. So if I put this here, okay, let's see that as an example. What happens if I take that indent off? White spaces are very important. And if I take this, it says expected an indent block. And that is really bad. So that's not the right way of syntaxing. So if you're using a good IDE, it should automatically do this for you. Otherwise, you will get these error. And Python makes use of these white spaces a lot, and you can see as we go. And we'll learn a lot about this. Great. And finally, let's do one more example in this. If you'd like to just try this out on your own, create a text and create another text file. I'm not going to show a solution to this, but this is just for you to practice. Create another file, put some text in it, and try to use the for loop to print just like this, and see what happens. And it's important for you to try this out. Next up, let's learn about sets and booleans, and I see you in the next class.